Hello and welcome to the Objective-C final class. This is actually kind of an extension class. There was just a couple more things that I needed to talk about in the original syllabus that had been put out, but it's kind of grown. There's a lot of things that I had wanted to cover outside of the things that were originally announced for the Intense Crash Course. And tonight we're going to be doing something a little different. I'm going to have those of you that are joining me over in BuzzNet right now follow along and participate with helping to create an application in Objective-C that is going to put everything that we've done up to this point to good use, along with a bunch of new stuff. So it's a relatively big application. It's gonna take us a while tonight. So hopefully you guys, Mr. Rowdy, Matthew, Terry, are ready to get this going. Mr. Lewis, but I thought it would be a lot of fun for us to come up with an application that got Nelson drunk. Yeah. So something a little more entertaining. So the things that we're going to be talking about tonight. We're going to be going over properties, protocols. We're going to be talking about memory management. We're going to be looking at, I'm also throwing in switch statements, enums. We're going to be going over some different types. We're going to be using NSMutableArrays arrays so that we can have collections of data for us to work with. And there will also be a homework assignment. This will be a homework assignment for those of you that are participating. So for those of you that are not participating, you don't have to worry about it. But I know how much Rowdy loves his homework, especially ones that contain challenges. And so I wanted to make sure that that was something that we could put out for you guys tonight, and then make ourselves available in, once again, an upcoming unannounced session, one that we'll just keep off the calendar, in which we'll go over that. And then I've got some other things that we're going to do that's going to be kind of cool as well. Actually, not kind of cool, but I think very cool. So kicking things off tonight, let's walk through just making an application. No reason for us to do a review because we're going to get a massive review going through and building all of this. So what I want to do is I want to have an application that will allow us to have a person. So let me come over here, and 1 second. Let me make sure that we're in the upper corner. Good. I don't want to waste space here. All right, so we got a person. So we'll be able to instantiate a Nelson. And then, oh, hang on 1 second. Nina wants me to move this out of her way so she can see stuff. And
thank you.
There you go. Well, even with just this little bit, you'll see if somebody puts something there.
Yep.
Okay, so we've got a person. Now, this person is going to want to, since it's Nelson, right? He's going to want to drink beer. And since we're not dealing with nude women and things like that, I figure that beer would not be offensive to anyone.
No.
And I know right now Nelson's probably sitting on the edge of his chair as he's now thinking about beer. So we need beer. But where do we store our beer? We need it to be cold, so we're going to need a place to store it. So we're going to store the beer in a refrigerator. So what I'm doing right now is I'm just going through and starting to kind of design the overview of what this application is going to look like. So these are going to be classes, but it's going to slowly become more and more involved. So now we have the ability to instantiate a person. We have the ability to, or we will, but I'll just say it as we have the ability to, instantiate a fridge, and we can instantiate beer so that we can put beer in our fridge, because that's where I keep mine. So a few more things. Well, where does the beer come from? Well, we go and we buy the beer from the store. The brewery. Very good, Mr. Lewis. Very good. We won't go that far back, but we want to be able to send Nelson to the store to buy beer. Now, why am I doing this? I think this is an awesome, awesome way to wrap up everything that we have done all the way up to this point, along with introduce some new concepts, such as protocols and working with NSMutable arrays and all, and actually getting to see all of this in action in a functioning program that we build from ground up. And something that does something more than just, says hello world, because we haven't really got into anything big, So I need something else now. I needed an environment, because I need for us to know things like time. And the reason I need an environment is because I would like for the store to be able to control when it's open and closed. So let's go ahead and come over here and give ourselves an environment. And let me click off that. Okay, Nina, I need 100% of your attention because I'm going to start calling on you real soon.
I was answering Keely and stuff.
So MMO Dust brings up a point of 7-Eleven never closes. Yeah, that's something to keep in mind or to think about in case we want a store that never closes. Okay, so this is probably enough for us so that we could actually have a bunch of object participation. Again, in this overall concept of a larger application, the cool thing that you guys are also going to get out of this is seeing the memory management that's going to be taking place. Because once we start passing objects around, because think about it, if we have, all right, prepare for scribble, if we have beer that starts out at the store, and then a person goes and buys some beer and puts it in his fridge. And then later, the person decides to grab one and consume it. And then he begins to become intoxicated. Yeah, we need to have intoxication too. Yeah, we're going to do that. So we need to be able to have Nelson get nice and drunk and start ranting about ponies and doing things like that. But take a look at what's happening here with this particular class. When it's instantiated into an object, see how it's getting thrown around? It's over at the store, so the store is going to have to claim ownership. It's then going to be put over into a fridge. The fridge is going to have to stake ownership, and then we're going to have it removed from the fridge and consumed. So there's going to be retaining and releasing and having to be aware of when retaining and releasing is required and when auto-release is something that is also there to help you out, and you may not be aware of actually getting an instantiated class that is already auto-released, which we'll talk more about that a little bit later on. But and then you turn around and you start trying to do things like release it yourself, and then you end up over-releasing. So again, the big picture is going to be quite nice here. So let me take off some of this scribble. So far, over in BuzzNet, pretty simple stuff, guys. I mean, what I've drawn so far, black and white. Okay, good. So let's go ahead and push this a little bit further. I want for us to be able to simulate time. I've also pointed out that we're going to have this environment, which is going to keep track of time so that we know when a store is going to be opened or closed, and if we can actually purchase beverages from the store. Now, another thing that would be handy with having the ability to track time and time progress forward as we're sitting here with the application running it is when beer is removed from the store and placed in your fridge, it begins to get chilled. And let's say Nelson only likes to drink his beer when it is at a certain temperature. So that way, if we tell him to get a beer out of the fridge, and he does, but it's not yet cold enough, he's just going to complain to us. So what I'd like to do is set up a system that allows us to have objects that are simulatable, okay? And this is where we're going to take our first look at protocols. So with a protocol, we're basically able to create an interface that we can then turn around and have a class adopt, okay? And that's the terminology that Apple uses, is we're going to adopt a protocol. And for those of you that are coming from like the .NET world, you know, we're implementing an interface, and I'll use those words interchangeably tonight. But I want to basically create an simulatable protocol so that I can then have objects that need to be able to simulate something automatically respect that ability. So, and this will make a little bit more sense as we work our way forward. So let's go ahead and, so protocols. What we're going to do, and also, as we progress further into this and I end up switching over to another whiteboard and start talking about syntax and things like that for protocols, do understand that the naming conventions for protocols in Objective-C is the same as classes. I will not be following that naming convention. I will be following the .NET naming convention, which is using a capitalized I before the actual name. I have always been a big fan of that because these protocols are nothing more than interfaces, and I'm able to quickly look at my Explorer and tell which of my classes are interfaces. So we're going to have an iSimulatable. Nina, is that a word? Simulatable?
I think so.
Okay, if it's not.
Well, it is now, darn it.
If it's not, it is now, I tell you. Okay, so with this protocol, there are things that I would like to have adopted. For example, the environment. Here's a great one. The environment, I'm just going to come up here and put iSim. Yeah. So that means we're adopting the iSimulatable protocol. This means anything that is inside this protocol that is marked as required must be implemented in environment. If we do not implement a required method or property in environment, the compiler is going to be like, no, we've got ourselves a problem. Now, why do we want to simulate, or what do we want to simulate in environment? We're going to want to simulate time. And we'll set this up very simple, where it's, of course, going to be a console app, but we're going to sit there, and if we just hit the enter key, as we are in what will be kind of like our game loop, as we hit enter each time without giving any input, that's just going to simulate time moving forward. It's just going to simply increment an hour at a time, okay? So in the case of our environment, it'll be time. I also want our fridge to be simulatable. Over in BuzzNet, tell me, Mr. Terry or Rowdy or Matthew or Mr. Pencil, why would we want the fridge to be simulatable? What would we want to simulate with the fridge? Temperature. Outstanding. So as time goes by, we can simply call upon simulate inside the fridge. The fridge could take a look at all of the different beverages that have been stored in, and then modify temperatures accordingly. So let's see, what else do we want to be simulatable? Oh, this one's a given. Why would we want the store to be simulatable? Open hours. Are you guys sure? How about when we go to instantiate a store, we're going to tell the store to, what I'm planning on doing is I'm planning on creating our own custom constructor or our own custom init for our store that's going to take in an open and a close hour. So we don't need to simulate the actual time with the store because the time's already been being simulated with the environment. But if we have the store aware of the environment, it'll be able to get the time accordingly from the environment. And Terry, BuzzNet was giving me fits as well, sir, at the beginning. So you hear that, Nelson, just pointing that out. So if it's not going to be open and closing hours, what else could we do with it? So, all right, let me generalize this a little bit more. We're going to start out by stocking our store. I mean, we obviously need to stock it with beer in order for there to be items in the store that a person can purchase, correct? Does that make sense? I'm trying to keep all of this very relatable to the real world. Mr. Lewis, absolutely. Sorry, Terry, Mr. Lewis beat you. Inventory. If we start out with the instantiation of a store, so now that we have an actual concrete store, and we populate it upon instantiation with an inventory, what's Nelson going to do? Nelson's going to go in there and buy everything. And then, you're right, he's going to purchase, Mr. Rowdy. But once he's purchased everything, if we don't have a way for the store to go about restocking, I mean, I guess we could simply set up flags so that, if the inventory drops below a certain point, then, we're going to add to the stock, blah, blah, blah. But what I'm going to do, and again, this is just so that we can really see how we can make good use of protocols all over the place, is I'm going to let the store add a new beer to its stock, to its inventory, every time an hour ticks by. So every time we get a simulate on time, that's what store is going to do. So now, would beer need to be simulatable? Oh, we're designing this, Terry, so that you guys can very easily put all sorts of different kinds of stuff in there. So I'm glad you said that, because that's going to be something you guys are going to be playing with. But beer, does it need to be simulatable? And if so, why? Again, simple model that we're designing here. Beer warming up, that's interesting. Expiration date, that's interesting. If not drank, cool. So good, you guys are starting to think outside the box. I want to keep this simple. So in this case, since we only have, 6 to 7 hours tonight before everybody starts dying, let's not make it simulatable, but you're absolutely right. Beer warming up was the one that I was originally putting in here, so that if a beer was removed from the fridge but not drank, its temperature would start to warm back up. So it's excellent that you guys are putting this information over here, because this is what I'm looking for. But in this case, what about full and empty? Ooh, that's a good one. In this case, no, not with simulatable on that, because what we'll do is we'll just simply tell a person to consume the beer, and then the person can grab the beer from the fridge, as long as there's one in the fridge, and simply consume it, and then act accordingly. So we won't get too complex of a model going there, but I did like the warming up, the temperature adjustment, which is a very nice one. So anyways, with beer, we're not going to make it simulatable. But as you guys have already pointed out some good examples of why we might want to make it simulatable. And Mr. Lewis says, how do you know? Oh my goodness gracious. Okay, I won't say what Mr. Lewis. I missed what Rowdy had said originally. You almost caught me there on video saying that. Nice job.
That was awesome.
What about person? Should person be simulatable?
Yes.
All right, Nina, why do you think person should be simulatable?
Well, whether they're drunk or not.
Ah, very nice. Whether they're drunk or not. That I concur with. Why? Because we're having a good time with Nelson, or at Nelson's expense tonight. And we're going to see just how crazy he can get if he is drunk. So let me over here on the side, way over here on the side, we're going to be referring to something tonight called back. And what do you guys think this means? Very good. Yes, I'm getting flooded with answers. Outstanding. The blood alcohol content that a person is going to have.
I should have known that.
So I just wanted to put that over on the side and now pretend that you are all experts and you know about it. So anytime you see me referring to back, I'm going to be referring to the blood alcohol content. I know, Rowdy, but some of these things are all we're going to get it crazy big tonight. And Mr. Lewis, we will be dealing with limits as well tonight. We're actually going to do some utility stuff as well, which is going to be a lot of fun. Okay, so now that we know what types of classes are going to adopt the iSimulatable protocol, let's go back to something that Terry had said a little earlier, and that was different kinds of beverages? Absolutely. We don't want beer to be the only beverage that this application will accept, because then we code ourselves into a horrid corner as far as extensibility goes. And of course, the moment we deploy this incredible application and all the kids around the world begin playing with it, they quickly decide that they want to jump from beer to Jack Daniels and other incredibly powerful alcohols. And what happens? We've locked ourselves into the only alcohol that this thing has, which is beer. Come on. Come on, Nina. What does beer taste like?
I don't know.
She doesn't even know, guys.
I've never tasted
Nina's
it
like
ever in my
21
life.
years old, and she's never drinking.
You said 21.
I did say 21.
That was awesome. I
She's
love you.
never, ever had.
Not even a sip.
So how would we go about making beer? How would we go about designing the classes here so that we could make it extensible? So that we have flexibility to do exactly as Terry had said earlier, and that is offer different kinds of beverages. Okay, MMO says alcohol class. Now, Nelson's probably in his room right now looking up where you live, Matthew, and he's going to come out there, visit you, and smack you with a fish. Because by saying alcohol class, that means you're probably thinking inheritance, which means then we'll have beer and Jack Daniels and other types of things inherit from. But what about 7-Up or Pepsi
Yeah,
or
you need
Coke?
your mixers.
That's not an alcohol. So look how quickly we've run ourselves into a problem with just the concept of something to drink. Ooh, Mr. Lewis is all over it. Beverage. Okay, so we could have beverage. And Pencil said the same thing, a beverage class. But I really want you guys to start thinking a little differently. And I know that most of you guys are not new to programming. And I know that we do have a couple that are completely new to it. Once people learn about inheritance and object-oriented programming, the first thing they think of is everything must inherit. Oh my goodness. And that's not the case. You want to use inheritance wisely. You want to use inheritance in situations where you're going to inherit code. You're going to inherit functionality that you will have on a superclass. And then the extended classes, you're going to have multiple extended classes all inheriting from this one superclass that are going to take advantage of code that has already been written. But we're now talking about beverages, where these beverages are going to have their own way that they're going to be responding. We're not going to be borrowing code from everybody, meaning each beverage is going to have its own name. Each beverage could go about controlling its own way that it's going to have temperature modified, etc. What I want you guys to start getting into the habit of doing is thinking protocols, okay? Again, a protocol is a way to enforce a class to implement required functionality and properties. It's a contract. And by taking, say, beer and adopting a protocol, in fact, I'll go ahead and write one now. What would be a good general protocol name for, Mr. Lewis has already said it. I'll just write it out because he's already said it. We're going to use iBeverage. There we go. So now with iBeverage, we can state in a contract that every beverage must basically adhere to a contract saying that it has to have a name. It has to have a temperature. It has to be able to tell if it's been consumed or not. And then we have to have the ability to adjust things like modifying its temperature and all. And now looking over in BuzzNet, Mr. Shavings and Mr. Lewis, we see coffee, question mark, and we see tea, and in Texas, Dr. Pepper. Well, with this concept here, we will have a blood alcohol content modifier that will be part of the protocol. But if you have something like tea, the back modifier would be 0. So drinking it would have no effect whatsoever on your blood alcohol content level. So this gives us the flexibility of having any type of alcoholic beverage. Now we could go in later and extend it to have, if we wanted to start being able to mix drinks and things like that. But remember, we're just looking at this right now as a simple product that the store is going to contain that is going to be of type beverage. And here is where hopefully you guys are really going to start to see the power. Let me go ahead and write this one down real quick. Of working with protocols. I don't want to code, because if we didn't use iBeverage, and we're just using beer, we would have to code the fridge for holding beer. We would have to code the store for beer, and we would have to code the person for beer. The moment we introduced a new type of beverage, now what do? We've created ourselves a problem, because now we've got to go back and we've got to modify person. We've got to modify fridge. We've got to modify the store. Instead of having the person, the fridge, and the store aware of beer, all they need to be aware of is a type known as iBeverage. So then later we can go and add as many beverages as we would like, as long as they all adopt the iBeverage protocol, and we have to make no changes at all to person, fridge, and store. The whole system just continues to work. And MMO says the environment needs a way to handle the beverage after the person handles it. Well, could. The way we're going to do this tonight is we're going to keep things simple. CBuy's in there. Yes. All right. Good deal. We've got another person adding to my list. Happy. Okay. So what we're going to do, I drink. We're actually just going to put. We're just going to have consume. So a person's going to be able to consume any beverage. Because I figure that's the concept of a beverage, is that it's consumable. So we don't have to go quite as far out as doing I drink. But if we wanted to, I mean, we could have an I product, and then we could have the I beverage. This is really cool with protocols. You can have protocols adopt other protocols. So we could have an I product, and then the store would simply stock products, Poor Nina's so tired.
Oh, no,
Hang on one second. Okay. I think she's probably more awake now. But then as far as products go, some may be drinkable, some may be edible, and some may be bathable. I don't know. What else? I don't know.
Burnable. I don't know.
So I love that you guys are over here tossing out ideas. Freezable, very good. But I'm hoping that you're starting to kind of get the idea of taking, again, like store could hold products and beverages. We could have iBeverage and Consumable or iEdible. And so then we could put Doritos and chips and,
yeah.
or wait a minute, Doritos and chips, same thing.
Popcorn.
We could put popcorn and steak. I don't know, food. I'm drawing a blank. I'm starving here and I can't think of food at the moment.
Cookies.
What is wrong with me? Cookies, thank you. Tacos, things like that are edible, not drinkable. And then we could simply have those put in there, like nuts, exactly. And then we simply have the iBeverage and iEdible could adopt the iProduct protocol. And then as long as the store knew to stock products, it doesn't need to worry about, is it a beverage or is it
food?
Is it food or something else? So again, it's a very nice thing, so that later on, if we wanted to go back in and make modifications by adding new consumables, we don't have to change the store at all. As long as they're products, the store knows how to handle products. Again, so as you guys are already starting to do an awesome job of demonstrating over in BuzzNet, we could really start making this system very complex as we mimic more and more of the real world.
Oh, rowdy.
Unfortunately, wow, Rowdy, very nice. I'm speechless. Unfortunately, we don't have all night for coding out a very real-world simulation. So let's go ahead and clean off a little bit of our mess right here.
Oh, he made me snort.
So let's see. Let's go ahead. Okay, that was just too much. That was too much. Let's jump over here real quick into Xcode. Let's do a new project. Everybody's following along in Xcode, right? Right. Everybody, Xcode open.
Get ready.
File, new.
They should click their participate button.
Good point. Everybody, click your participate button. If you are running Windows and you're like, oh, but I don't have Mac and I don't have I don't care. Open Notepad. Click the simulate thing. Do it now. And what I want you to do is come over and click on a new project. And let's go ahead and we're going to be doing a command line tool. And let's call this tool Nelson's World. Dedicate it to you, Nelson. So we're going to be using Foundation, no automatic reference counting right now. I want you guys to be keeping track of everything that's going on, because I think by the time we get to the end of this project tonight, you'll have a really good understanding of memory management. So Nelson's World, go ahead and hit next. And I'm just going to store it in my programming, and I'm not going to be creating a local Git repository. So let's go ahead and create. Do it! And let's jump over here in the main, and this is what we got. Let's go ahead and kill out this hello world stuff. All right, you guys knock that out real quick, and then click your I'm done button. Faster, faster, faster. All right, fine. I'm hitting pause on the video so I can get a drink of my iBeverage.
Let's do this.
Okay, and we're back. So next thing I'm going to do is let's go ahead and start out by creating our major classes. Some of the things that we were just designing out on the board. So, and I'm not going to worry about jumping in with any protocols at the moment. We'll get to that in just a second. But let's just do some of these big classes. And let me grab the right mouse here. So I'm just going to come over here and hit Command N. And we're going to create, I'm going to come over here to Cocoa and do an Objective-C class. And hit Next. And we're going to call this first one Person. Everybody with me? And of course, it's going to subclass NSObject. We'll hit Next, and we'll just simply store it in our project. All right, next one we're going to do is going to be, so the person's going to need beer. So let's go ahead and do a Command N, and I'll just hit Enter and type in beer and hit Enter and Enter. So now we've got person, beer. We need a fridge. So again, Command N, Enter, fridge, Enter, Enter. And finally, Command N, and we're going to need a store.
Store, yes.
And Enter, Enter, and we need one more thing. What was it, ladies and gentlemen, quickly?
Okay.
Nina.
Environment.
Very good. We need an environment. So let's go ahead and Command N, a new Objective-C class, and this is going to be our environment. Okay, so at this point, you guys should have all of your major classes in place. I'll go ahead and pause for just a second, and as soon as I find my mouse. Okay, we're back. Okay, so now that we've got our major classes in place, let's go ahead and create our iSimulatable. But before doing that, you guys know how much I love whiteboarding stuff.
Yay!
So let's jump back over here and take a closer look at protocols.
Let's do it.
All right, so with protocols, as I've already said, the naming convention is the same as classes, which means you're just simply going to be naming your protocol just like a class. It's going to start out with a capital letter, and it's also, your file name is generally the same thing as well. Protocols, this is the important one here. The declaration is going to go in our header file. There is no implementation file for a protocol. So So declaration in header. Now the syntax is actually very straightforward. It looks like this. It's going to be a compiler directive at protocol. And then we need to give it an identifier, so some sort of name. In our case, it's going to be iSimulatable. In just a moment. And then we can adopt in our protocol additional protocols. And this is where we're going to come in there. And when adopting a protocol, you're always going to use these angle braces. Now you can adopt as many protocols as you want. See, Objective-C is a single inheritance language, which means we can only inherit from one superclass. But we can adopt as many protocols as we want, and that gives us a means of simulating multiple inheritance. Okay, so this is the syntax for getting it kicked off. Now, we do have two things that, well, let me just do this. I'm going to say at end, and this is going to tell the compiler that this is the end of our identifier, or excuse me, the end of our protocol. And then we have two more compiler directives that we can use. We have required and we have optional. Now, without specifying anything, everything that we put down here is going to be considered required. And that's all we're going to be dealing with tonight is required. But I wanted to say, or to point out that unlike C# with interfaces, with Objective-C, you can have optional members that do not require implementation. So just as an example, again, this is not required, but I'm going to put it here. So at require. And then we simply come in here and we start specifying the things that we want in there. And here's what's really nice. In the past, all we could have was methods. In more recent times, we can now have methods and properties. And since tonight we're going to be getting good with all of this stuff, let's go ahead and do both. So I can come in here and I can say at property, and then I can come in here and I could give it parameters for specifying how the property is going to be synthesized. So I could say something like, maybe I want this to be read-only, and I don't care about a multi-threaded environment, so perhaps non-atomic. And then I just simply say what type it is going to be and an identifier. And then I can also come in here and specify methods. So I'll come in with a dash and then our return type. So RTN type. And then our method name. And then if there are any parameters, you guys know how that goes. So let me go ahead and move this up a little bit. Let me grab my eraser and do a little bit of erasing here because I just want for you guys to see this real quick. So this right here is showing a required to implement section of members. If you wanted to have optional members, then it would simply be optional. And again, same exact thing. At property, blah, 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 blah. If you wanted to have multiple properties, and then methods, and then these would all be considered optional. Then I could even turn back around now and say, very nice, Rowdy, and then do another at required if I wanted to. And then continue on and switch back and forth, back and forth. Of course, I don't want to do that here. I mean, I wouldn't do that anyways. That just would be very confusing as far as somebody coming behind you later and looking at your code. You'd want to put all of your requireds at the top, your optionals at the bottom, and then finally your compiler directive for ending the protocol. So this is the syntax for declaring a prototype. So then the next question is, how do we use it? What's the syntax for using it? So syntax, and this will be for adopting a protocol. So it's very straightforward. In adopting one, in the class that will adopt it, we need to make sure that we tell the class about the protocol by simply importing it. So now it'll be familiar with it. And then, and again, we're inside the header. But more specifically, and I'm pointing this out only in case you're ever putting everything in a single file and you're not using a header and an implementation file, which you should, and you should be shot if you're not. But anyways, in the interface line where you're actually defining your class, in other words, so add interface. And then let's say I wanted to make something called my class. So that's the name of my class. And then I'm going to inherit from, and let's say I'm inheriting from NSObject. And then I want to adopt my protocol that I had up here, which I just called that one identifier. So let's just say that was its name. So again, putting this inside my angle braces, and it's that easy. Okay. So Mr. Lewis says, where does the code for the method go? That's implementation. So that'll go into the M file. Okay, so hopefully that answers that. So and we will be implementing all sorts of stuff tonight. And we don't have to go through the header and redeclare, because at this point, it's by adopting the protocol, the class is now aware of what is in the protocol, so we don't have to redeclare. And the compiler will know when you go to actually compile the program, it'll know what things are required to be implemented, and if you don't implement them, you guys are going to see that it is simply going to say no. It's going to not compile your application. So this is, there is one more thing that I can throw out there. So this is how you go about actually adopting a protocol. And then here is actually using, this is a great one. So using a protocol as a type. You don't see this as much in Objective-C. For those of you, I was originally going to put delegates into tonight, but then for numerous reasons, I ended up deciding not to. One, I'm a big fan of what we're doing here with this large program where you guys are going to see how all of these different gears interact with one another. It's going to be so much more valuable than smaller lessons over each of the different things, such as delegates, enums, etc., that we would be covering. But you're going to find that protocols and delegates work together very closely. And just about everything that you're going to do that's going to be any real Cocoa programming or any iOS programming. And so that is something that we will need to be talking about, because we're going to be dealing with those patterns and setups a lot when we're doing iPhone development. So that'll so we're going to end up having to cover that anyways in a more appropriate spot. But using protocols as a type was something that I was getting at back over on, well, not back over on this page right here, back up here, when we were talking about a person, a fridge, an environment, and a store are all iSimulatable types. They're so much more. A person is so much more. It has the ability to consume where the fridge is not going to consume an actual beverage. But at the core, we can say that a person is an iSimulatable type. A fridge is an iSimulatable type. So what happens when we want to start dealing with types that are of type protocol as opposed to the type that's adopting the protocol? In other words, if I was to jump back down here to the demonstrations that I was showing, here in the syntax for adopting, we are creating a type, a class called myClass. So that's now a type. So you guys all know that we could turn around and we could then instantiate that. But in doing so and holding the reference to this type, we must specify the type and then the identifier to hold the reference to it. So when dealing with protocols, it's kind of interesting how to know about doing this, how to set it up. So here's the syntax for using a protocol as a type. So we use ID, and we saw ID the last time we met when we were going over how to write init. Basically, ID is just, it's a generic way of saying some object. It's some object. But here we can say some object that adopts the protocol. And then we can just say identifier. No different than int x, all the way back to the good old days. Type, identifier. I'll just put ID, but you guys know what I mean, identifier. So there's your syntax. So an actual example would be, in our case, where we're wanting to throw the iBeverage around. Different people are going to be using iBeverage, and we don't want to have to turn around later in time and, you know, if we code it for a specific type of beverage, in this case, beer, we don't want to turn around later and be like, oh, I can't do that. So the only thing that like a person needs to be aware of is going to be this beverage that is going to be using iBeverage. So here's how we would go about actually declaring a type of iBeverage. Now, beverage can actually hold a beer or any other class that adopts iBeverage. Okay? So this is an extremely important concept to understand, because this is going to allow us to loop through inventory and talk to everything that is of type iBeverage, or to pass types of iBeverage into other objects to work with. So it's very, very important. Composition, absolutely, Rowdy. Very good. So, so now that we've taken a look at protocols, let's go ahead and jump back over to Xcode. And I'll come up here, and you guys should be able to follow along with me pretty quickly. And let us start out with our first one, which is going to be our iSimulatable. So what I'm going to do is just simply hit Command-N, and I'm going to come down here to C and C++, click on my header file, hit Next, and then what I want to do is call this header file iSimulate, or Simulatable. And then inside of iSimulatable, I'm not worried about any of this stuff. I'll leave those comments there just for Nelson. We want to make sure that we import. And then we need to bring in our foundation. Actually, in this particular case, hang on. No, this is going to let me talk about something else that I think would be really cool for you guys to see. Yeah, let me leave that out for just a moment. Let me say add protocol, and then the protocol name is going to be iSimulatable. And notice how NSObject right here has been added on as a protocol that we are adopting. And if you guys recall, NSObject is the root level object in Foundation, in which all Foundation objects are comprised from. We don't need this here, but we are going to need it with our beverage. And sometimes you will see NSObject being included, and sometimes you won't. And I will, I'll make sure that you guys understand clearly why here very, very shortly when we get around to iBeverage. So inside of our iSimulatable protocol, we need only one thing, and that is going to be simulate. So what I want to do is I simply want to make sure that every class that adopts this protocol for sure has a simulate method on it, so that I can call it simulate method when we need to run the simulation on everybody. Okay, so go ahead and type this out really quick. Very good, yes. Remembering how those buttons work is a fantastic thing. And then go ahead and hit your Command B to make sure that all blows up. Just kidding. Make sure you haven't got any typos in there.
Typos are the devil.
Oh, Mr. Pencil, come on. Hop back in there, my friend. There you go. Thank you very much. You the man. Okay, so now that we've got this set up, let us turn around and let's make use of the protocol. So let's start out with person. So what do we need to do to get person in there? You guys should already know with everything that I have I've put out on the whiteboard to make use of this iSimulatable protocol. What do we need to do? Well, here we are in our header file for person, and I can start out by saying I'm going to import, and I want to import my iSimulatable header. And then I'm going to turn around and I'm going to adopt the iSimulatable protocol, like such. And real quick, while you guys are typing that out, Nelson, are you with us still?
Yep.
BuzzNet is giving a lot of people difficulty tonight, including me. I don't know if you may be aware of why a lot of people are having issues with it.
No.
All right, well, I mean, you as the designer and programmer, I figured maybe, but okay. So you can go ahead and hit mute now.
Fine.
Could you hear it?
So if I turn around and hit Command B after putting this guy in, take a look at what happens. We've got some interesting information that is being given to us, don't we? So over here in person, we have incomplete implementation, because person now needs to actually make use of simulate, doesn't it? I mean, that's the whole concept of having the protocol. So what I want to do is let's just come over here real quick and say, all right, well, fine. We know that this guy is simply a void simulate, open, close, and Command B, and I no longer have any warnings, errors, anything. So make sure that you go ahead and you put the simulate in. So we're just getting this skeleton in real quick. And now what I want to do is I'm going to turn around, and just to make life a little bit easier for myself, I'm going to come back over here to the person header file. I'm just going to copy this line right here for iSimulatable for importing it. And we want to turn around now and think about who all was going to be implementing it. And as we had said over on the whiteboard, we know that person needs to simulate it for his blood alcohol content. We know that our fridge needs to simulate it. Who else needs to simulate it, Nina?
The store.
The store needs to simulate it so that we can restock our inventory. It's just a real easy way to go about doing that.
An environment, right?
And then we have our environment that also needed to simulate it. And why did it need to simulate? For time.
Time, yes.
That's right. So we'll jump over here, and we will throw this guy in as well. And so now let me just jump in here, and I know I'm being lazy. I'm just going to copy this and jump back through and tell each of these classes that we just told to import iSimulatable that they're going to be adopting this protocol. So Command C, and then I'll just jump over here to my, fridge, and paste that in. And then we want to come over here to the store, paste that in, and our environment, paste that in. And then finally, I'll jump back over to my person implementation. I'll simply highlight and copy my simulate implementation. Even though it's empty, I'm going to take it and put it over here in my fridge.
Put it in the fridge.
I'm going to put it in the store. Again, implementation files. I'm going to put it in the environment.
Dun, dun, dun.
Command B, build it out and make sure that we have no warnings, no errors, and that everything is completely happy. And with that, I'll go ahead and reset so you guys can let me know that you have it complete. Plus, we're going to be taking a break now because we've been going for just over an hour, and we will be back. So I will pause video. Okay, guys, we're now back from the break, and I do believe everybody is caught up. And for those of you that have joined us, Jonathan, please make sure to hit the participate button because
Yay,
I'm
Jonathan's
actually
here.
forcing that upon people tonight, and you'll just have to like struggle to get caught up, but it'll be fun.
You can do it.
Work with you on next break if need be. Okay, so now that we have, if we jump back up here and take a look, oh yeah, let me go ahead and undo what I was talking about on break, getting people caught up. So we have come in here and we've put a skeleton. Well, actually, we finished the protocol for iSimulatable, and we have put in a skeleton for person that's adopting it, for fridge that is adopting iSimulatable, for our environment, and for our store. So no implementations are in place yet, but we're starting to see an application come together, which is, again, really cool. So the next thing that I want to do is I want us to go ahead and create the iBeverage protocol. So let's go ahead and jump back over to Xcode, and I'm going to use the other mouse to reset you guys. Okay, so for this, what we're going to do is come in here, and I'll just hit Command-N, and let's use the Objective-C protocol this time around. The protocol, the template that is, the protocol that we're going to create this time is iBeverage. And I'll hit Enter. I'll hit Enter again to go ahead and create it. And as you guys can see, we've got a header file created. So just like I did manually when I created the header file earlier, which is just out of habit for me, just like iSimulatable, except here, notice that we've got the protocol iBeverage is adopting the NSObject protocol. And as I had started to say earlier before break, you guys are all aware that NSObject is the root level class for all objects in Foundation and most everything that we do. There is also an NSObject protocol as well. And NSObject adopts NSObject protocol. May seem kind of weird, but I think it'll make a lot more sense here in just a moment. Because you'll notice with iSimulatable, we're not adopting NSObject. And I wanted to do this just because when you guys start looking at other libraries that are out there, and I guarantee you that you will, if you take your iPhone and iPad application development serious, you're going to be using, there are some amazing, especially with networking stuff, amazing free libraries that are available that you can make use of. And if you're looking through their code for ideas or examples on how they go about doing things, you'll see some protocols that are not adopting other protocols, and you're going to often find protocols that are going to be adopting NSObject, and this will just let you guys see what's going on and why. So I thought that would be handy for you guys. Okay, so what I want to do first is go ahead and set up some properties. And then we're going to talk about properties. So let me get my mouse back over here. So the first thing we're going to do is we're going to set up a name. We want a temperature, we want a back modifier, and we want an is consumed. So here's how this goes. We've lightly seen protocols in the past. So, or not protocols, properties. So I'm going to say property. And now with the property, what I'm going to do is I'm going to give some instructions to the compiler how I want the accessor methods synthesized. And we'll talk more about this in a minute on the whiteboard. But this is what I'm doing. I'm giving instructions to the compiler right now. And I'm going to tell it that I want the very first property that I'm going to create for the beverage is going to be a name. It's going to be an NS string. Because think about it. When we adopt this protocol and we, with a new class, say beer, we want to make sure that we can identify that as a beer, right? And if we did Coke, we want to be able to identify that as a Coke. And we're going to store that in a name. So let's go ahead and say property I want to retain. I'm going to make this read only. And you're also going to find that I'm going to be throwing in extra stuff that from time to time, as we work further in, that's not necessarily needed, but I'm wanting to demonstrate as much as I possibly can. So read only, and I want this to be non-atomic. And non-atomic, in this application, it's not important at all, but non-atomic is something that's very important to me, especially when we start doing iPhone development and we're working with limited resources. So you'll see what it means in just a minute, but it deals with multi-threaded applications, and if we were to have two threads that are both accessing this getter or setter. So let's go ahead and now with the property, now that we've given instructions to the compiler how we want the accessors synthesized, now we need to tell it what the data type is going to be. So it's going to be in a string, and then we need to tell it that it's going to be, in this case, name. Okay. Okay, so first, very simple, first property. So let's go ahead and make some more real quick. So we're going to do another property. And this one is going to be for our temperature. So this is going to be a read-only. Notice I'm not doing a retain here. So this one is going to be read-only, and it's going to be non-atomic. And it's going to be, because we're going to use an NS integer. And with this NS integer, it's going to be temperature, not template. F for Fahrenheit. That's right, it's a primitive type. So, well, let me change that. This is a value type. So retain is an object. So this is going to be a heap-based object. NS integer is a value type, so it's going to be a stack-based object. So if you try retaining it, it's not going to work. All right, so, and setting these as read-only, what I'm trying to do is be respectful to the concepts of object-oriented programming that we talked about in our last meeting and the meeting before that. One of the things, as you guys recall or may recall, is that we spent a little bit of time talking about encapsulation. Encapsulation is very important. And respecting that is critical. You don't want everyone out there being able to go in and modify data that needs to be protected or modified only by the class that owns that actual member. So by setting it as read-only, it's not, Rowdy asked over in BuzzNet, he said immutable type. It's not that this is making it an immutable type. It is making it so that anybody external to the class that is going to be adopting iBeverage cannot go in there and change temperature. They're going to have some other means of going about doing that because we're basically locking them out by saying this is read only. Okay, and it'll make, there's no setter. This is going to make a lot more sense as we start actually, I'll be drawing this out on the good old whiteboard in just a moment. Okay, so now that we've got an NS integer in there, let's go ahead and do just a couple more types real quick. So property, man, my fingers just do not work tonight. For this one, what we want to do is a back modifier. So we're going to do read only, and again, non-atomic. And this one is going to be just a regular float. Like I said, I'm trying to mix everything up in here. And this is going to be our blood alcohol content modifier. And then finally, our property for is consumed. So read only. And this is going to also be non-atomic. And it is going to be of type bool is consumed. Now, that's our properties. Let me go ahead and put our methods in place, and then we're going to talk about properties over on the whiteboard. So the next thing, yes, I know, Jonathan, we already talked about the blood alcohol content modifier and naming. That's why I put it on the board all the way over to the side. I don't want to type out a million extra letters because some of the things are already going to get a little long tonight. So continuing on, we're going to go ahead and set up our required methods that must be implemented by anybody that adopts this protocol. So we're going to have all beverages that use the iBeverage protocol must have a init with temp. So I want to make sure that we have the ability to initialize a beverage with a given temperature. I'm also going to simply have init and have it default to a temperature, but we'll worry about that when we get over into beverages. So like beer. So let's go ahead and do our init with temp. And then this is going to be an NS integer, and it'll simply be the temp. We're going to have void consume, because we want all beverages to be able to be consumed, and we want them to be able to respond accordingly. If we want them to do anything beyond what we're going to have them do in this application here. Again, flexibility, extensibility. We're coding for that, even though there's not a lot of use that we're going to make out of this. We're going to put it in play so that later on it's already there. Okay, so one more, and this is going to be our, again, void return type. This is going to be our modify temperature. And this will take in an NS integer, and we'll just say by temp. Okay. Every iBeverage type that we create must implement these things so that I know that I can safely go about having a person, a fridge, and a store interact with beverages without having to be concerned with the specific type of beverage, allowing me to easily add more beverages in the future without having to go back and touch any of those classes. Very important concept. Okay, so what I want to do now is jump over here to the whiteboard, and let's see if we can find ourselves a new area to write with. Yeah, I think we can make some stuff fit right over there. Okay, so properties. Is an easy way for us to do less typing. It's that simple. As we've already said in the past, and Jonathan, I'm glad you're here. I just thought about something. Remind me later on to talk to you and everybody else in the class about public, private, and protected. That came up in one of our, I think it was the last time we met, and I was in the middle of talking about data members and, methods, and I had said that there was no mechanic for setting public, private, and protected. And that's correct. There is no mechanic for controlling that. Is there a semicolon modify temp? Oh, did I mess something up? Hang on, I'll switch back over and take a look in just a second. But anyways, there is no mechanic for controlling that. There are other ways to go about controlling if something is public or private. But when dealing with data members, you can use compiler directives to say if they're public, private, or protected. So I just wanted to point that out real quick, and we can talk about that a little bit later on. But I was specifically talking about methods at that given time. Now let me go ahead and switch back over to Xcode real quick. And where did I? Oh, I didn't mess it up. You're just asking if there needed to be one. My bad. Yes, there needs to be a terminator at the end of all of these declarations.
Need a terminator.
That's right. So let's go ahead and Command Tab back over. He means a colon. Oh.
What? Huh?
For him, not for me. Oh, wait. I did leave a colon out. Haha. Yes. Thank you.
Ta-da!
I was looking at Terminator. Sorry, let's go and switch back over. Thank you very much. I love it when you guys are paying close attention. It makes me happy.
You guys get a
it's
gold
like
star.
Everybody's not asleep. I like it. Okay, so with properties, again, it's all about the accessor methods. As I've said in the past, when we create data members, when we define or declare those in the interface portion of our class definition, we then need to turn around and expose them to other classes that may need to use them. So in doing that, the approach is to write what's called accessor methods, which is a set and then whatever the data member's name is, method, and just whatever the data member's name is, a method by that name, and that's the one that's going to return that value back. So if I was to, so basically a very, very crude way of doing this. So pretend this is over in the interface section and we've got our data members. So if I had an NS string and we called it name, then in our implementation section, we could have a, so we need to set, so set's not going to return anything. So set name, and this naming is very important. We're getting towards synthesizing, absolutely, Mr. Lewis, but I'm kind of wanting everyone to see the why. Why do we need to synthesize? So set name, now of course set name is going to need to take something in. It's going to need to take in an NS string pointer. And we can say new name. And then in here, blah, 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 blah. So this here is going to be where we would actually set it. And then we would turn around and we would also have, so this is a setter. We would have a getter that we would also make available. As a matter of fact, you know what? Let's just do it this way. Let's just say that we're still inside, instead of doing any implementation whatsoever, I'm just going to put a terminator at the end, and I'm just defining these guys. So we would also come in here and we would declare our getter. So the getter is actually going to return the type. So it's going to return an NS string pointer. And then its name, again, very specific, would be the same as the data member. So it would just be name, like such. And then in the actual implementation, this would simply say, so now let's stipulate this is over in the implementation file. Inside the implementation for this method, we would say return name. So this allows somebody to externally, meaning outside of this class, gain access to this data member. This allows somebody externally to set this data member. Now we can use the points to operator to go in there and set that, but I'll be choking you guys if you do that. Later on, if you guys want to look at the public, private, and protected compiler directives for data members, I can talk to you real briefly about the points to operator or the indirection member operator, I think is what Nelson likes to call it. But we can take a look at that. But we would want to go about actually using getters and setters. Now, this results in us using getters and setters having to prototype out these two methods. Then over in the implementation file, we have to go about implementing them. Now, I kept this as something very simple at the moment. But if I was to implement this set name, help me out here. What would the implementation look like? So this one, I think this is kind of important. So if I was to, now we're actually implementing. So if I had a void and set name, and set name took in an NS string pointer, and I'll just say new name, and then boom-ki-dink, and boom-ki-dink, and then what would go inside here? So Jonathan and Terry were real quick to say name, very good, equals new name. Very good. You've just created yourself a problem. Thank you, Mr. Rowdy. Retain. This is extremely important because we're dealing with, think about this now, we're dealing with a data member that we're wanting to set a value on. So all the way back up here. So again, he's a data member that's going to stay active with this class throughout its entire instantiated life. Okay, so this actual object. Meaning when we give it a name, if we do just this right here, what do we know about this guy? What do we know that is happening with this actual object that's on the heap? What do we know about any other variables that are pointing to it? They could possibly be releasing them, right? What I'm getting at is we don't know what is happening with new name after we call this method here and we set the name with new name. So whoever called this method set it. What if we then turned around and released it? So what if the retain count was only 1? And we'll go back over retain counts again tonight. But the moment we go to a retain count of 0, as Mr. Rowdy just said, bye-bye. Retain count of 0 causes a deallocation to take place. Well, now we've got a problem. Because if we've released it, now we're and it all depends on, well, Jonathan, maybe not. Jonathan said, for those of you that are watching this video in the future, he said blue screen of death. Not necessarily. You can release and then turn around and set that object to nil. Well, no, even that's going to end up getting you into an interesting bind. Yeah, you're going to end up getting yourself into a problem. So when handling memory management, you want to make sure that you're going to tell this guy that we want to retain it. So in this particular case, what we would want to do is be to come in here, and I promise you guys, if in case you're thinking, man, why we've already talked about all this stuff, you're going to see why it's very important here in just a moment. You're going to want to say that this new name that's coming in, let's send this dude a message. Right off the bat, I want to retain him. And then I want to come in here and tell my current name that, look, we're going to release you. Because remember, at this point, here's name on the heap. And here is new name. So I'll just say NWN. That's new name. Okay, good. Just deal with it. So at the moment, we are holding on to this guy. So let's say that this guy's retain count was only 1. Nobody else had ownership of him. And this guy's retain count was 1. But whoever called set name is going to be releasing him once we are done. So what ends up happening is by coming in here and saying we want to retain new name, this guy gets bumped up to a 2. We want to release whoever name is currently pointing to. Well, name is currently pointing to this NSObject right here, this NS string. So 1 goes to 0, and since nobody else had staked ownership in him, he gets deallocated. And we now own this guy. When we return back from the guy that actually called set name and set the name, he does a release because he doesn't know what happened in set name. He's like, look, we're going to set the name. You do with it whatever you want. So when we return back, what happens now is we call release, and this goes down to a 1. So we're still up by 1, which means that's why we're going to have a deallocate method. We're going to need to override it and deallocate name ourselves to make sure that we release ownership of it, which in this case, as you guys see, would bump it down to 0. All right, let's see. What did Rowdy say? What would happen if you did not release name? We have a memory leap.
Leap.
We have a memory leak.
You're going to leap your memory.
Leapfrog, yeah, me and my tongue. So now let's back up with what Rowdy just said. So let's say that we have a program that we've created this cool game and we're shooting projectiles at a crazy rate, right? And so we're instantiating and firing out projectiles, and we're shooting up the wall because Nina's the one that's firing. She's missing the guy because she's like, her character's facing in a corner, right? You guys have all seen that. And you're like firing off millions of these objects and they're instantiating them. And let's say you're not using an auto release pool and you need to retain and release. Just as a rough example. This is the first crazy thing that came to mind. What happens is you're going to end up with all of these objects getting left hanging out there. If they're left hanging out there, your heap is getting more and more and more stuff just sitting out there. What ends up happening is your memory consumption for the app while running continues to expand and expand and expand. And we don't want that to happen.
Very bad.
So let's see, Jonathan just said on a desktop, which usually has 4 to 8 gigabytes minimum nowadays, it's not a big deal. Jonathan, don't ever say a memory leak is not a big deal. A memory leak is always a big deal. I can't believe we're not talking about performance. We're talking about leaking memory.
That's a demerit.
Oh, no kidding. Dunce cap is off of me. I had to put it on because I was talking to you earlier and you weren't even in here, and it's now been handed to you in the corner, sir. Jeez. So we don't want memory leaks. So that's, Rowdy, that's what would be happening. So we want to make sure that we are indeed properly releasing. Now, why did I go through the headache of writing all of this out? Well, you can start to see here, we've written both a getter and a setter. When we start using properties, with properties, what's going to happen is we're going to have this code done for us. So all of the prototype declaration stuff, all of the implementation stuff is being auto-generated by the compiler. But as you guys see right here, that it's not just a matter of needing a getter and a setter method established for us for setting the data member and then retrieving the data member, but we also need to be able to specify certain things. Like in this case, I need it to say, look, I want it to hold ownership to this. I need to retain it. So there's code that needed to go inside of the setter that, since we're going to allow the compiler to write the getter and setter for us, we need to be able to tell the compiler how to go about writing the code inside of the actual setter. So in this case right here, we need it to retain our name, right?
Right.
Exactly. So now if we jump back over real quick, oh wow, that was funny.
Pelicans!
So if we jump back over real quick into
flamingos.
here, let me try that one more time. If we jump back over into Xcode real quick.
I said pelican.
Yes, you did.
It was like on Scarface, remember? He was
boy.
like calling the flamingos pelicans. I just had a Scarface moment. Sorry.
Gotcha. So here is a great example of what I was just drawing out over there on the board. We're going to want the compiler to generate our accessor methods for us for an NS string object, and we want them, this NS name, we want to retain it. We want to hold on to that name so that if it ends up getting released by somebody else, we're okay, you know. Now, we're going to get to a point where we will be talking about the automatic reference counting. So I just want to throw this out there. One of the keywords that you're going to become familiar with later is going to be strong. So when using automatic reference counting, you've got to hint. You got to give hints to the compiler that this is how you want it to treat the data members, because it's going to go through and look at all of your code and put the retain and releases in for you. Exactly. So Jonathan just said strong and weak. And this is an example of where this would be a strong reference because we must hang on to this. We need to hang on to it for the entire time. Okay, so now you guys, at this point, for those of you that are completely new, have an idea of when writing a data member, the concept is we need to turn around and provide methods that we can then use to set and get the data from that data member externally from other classes. And we now need to know that we need to, we don't want to type a whole bunch. So this is where we're going to be using properties. So let's go ahead real quick, and I'm going to just kind of zoom back out for just a moment and grab my trusty eraser and get a big eraser. With this eraser, we shall come in here and we will do a bunch of erasing and stuff. Yes. So we do the erasing. And the erasing is almost done. And we shall leave name there and hit Command 1 and jump back in. And I did a horrible job with my erasing. I like the word. So now that we're done with erasing, let's come back up here and continue talking about properties. We have a data member called name. So still over in the the interface section, the next thing that I'm going to do is I'm going to tell it that we need to have a property. So we're going to give a compiler directive and say property. And we're going to have property attributes. So I'll just say property adders. Yeah. You can have multiple attributes in there. We'll take a look at them in just a second. And these attributes are simply, they're all contained within the open and closing parentheses, and they are simply separated with commas. Okay? So makes you feel like adders, makes you feel like udders. Makes me think of, not udders. Wow. Man. Makes me think of Meyer. Meyer? Ah! You and your udders makes me think of Maya. Okay, so continuing on. Good heavens. So the next thing that we're going to want to do is we need to, after giving out our attributes, then we're going to say that we've got our type.
Goodness. And
we're going to have our identifier. Jeez. Okay, as Jonathan completely derailed me. I like crashed right into a brick wall. Okay, so now that we have the implementation part in place for a property, now we need to tell, or the declaration part in place, now we need to tell the compiler to actually synthesize the methods. Now, we are not locked into a situation where we have to rely 100% on the compiler's generation of the getter and setter. Since these are methods, there are times, often, lots of times, that you're going to want to go in there and put some of your own logic. And this is one of the nice things about having a property. Instead of it just being a direct access to a data member, now it's kind of like an intelligent data member, because you could have that data member act as if it's responding to a health that's going below 0 or to whatever it may be, by simply having additional logic in a property. So while over in the implementation file, we have to tell the compiler to synthesize. So remember, this is in our header file, so it's part of the interface. And now what we're going to do is we're going to move over to our implementation file, and we're now dealing with, and I can't look at BuzzNet no more.
No, you really.
No, I cannot.
I don't recommend.
We'll save that for break. Wow. So now we're going to move over to our implementation file, and inside of the implementation, right after we say add implementation, we're then going to come in and we have to tell the compiler to synthesize. So at synthesize, and then you just simply say the name or the identifier. So if I was to say, in this case right here, we had, I've got type and identifier. So if we were actually making for this guy right here, I would have said NS string. There's our type, so it's an NS string pointer for name. Okay, and then in synthesizing, I would simply say at synthesize name. That's all that is needed. If with just this right here, when you go to build out your application, the compiler is going to take a look. It's going to see that we're going to be generating our getter and setter based off of the instructions that we provide with our property attributes. And then when it hits this actual synthesize section, the synthesize line right here will cause the getter and setter to be created using the property attributes that you specify right there. Now, you guys have already seen, I went through the great pains of drawing out a getter and a setter a second ago. Remember, you use the actual name of the data member, and we're not locked to that, but that's something we'll talk about in a minute, and only lightly. But we use the name of the data member, but with the word set at the beginning for a setter, and then we just use the name of the data member as the getter in a method for returning. Why am I saying this? What if we wanted to, let's say we wanted the compiler to synthesize the getter, but we wanted to write our own setter. All we would need to do inside our implementation is write an actual setter method for name that that use the convention that I already showed you guys, and the compiler is going to see, oh, he's wanting to synthesize name, but he's got a method called name that returns an NS string object. So, well, that's obviously his own getter. So let's just use that. We're not going to synthesize a getter. And vice versa. If I said to synthesize name, but then I wrote a method and prototyped it out and wrote it for set name, with set being lowercase and name starting with a capital N, and taking in an NS string object and returning void, the compiler once again would say, oh, well, he just wants us to synthesize a getter, but he is writing his own setter, so it overrides, it simply doesn't write the setter. Okay, so over here, Scion had a question, but then he said, oh, okay, then he said override, and then he said, yeah, and okay, everybody's on the page. Good deal. So, oh, I answered it. See, Jonathan, you jump the gun on asking questions. Let me finish talking. I had to stop looking over there because you guys were talking about utters in the most extreme sense. Like,
oh my, yes.
Like, yes, and I saw that movie too, Total Recall, for the record. Anyways, so moving right along. So as you guys can see, we have the ability to go in and give our own getter and setter. If we want to, and I'm only going to mention this, but we're not going to be using this. This will be something that we'll be spending more time with later when we get over into iPhone development. But what if I wanted to do both a getter and a setter? I mean, I could just go in here and define my own, but at that point, it almost seems kind of ridiculous. You can use, instead of synthesize, there is another compiler directive that you can use in the implementation section, and it's at dynamic. Oh, look at Matthew speaks up. He's been quiet for a while. I thought Matthew died.
Yay, he's here. He's alive.
I'm just going to hand this over to him and let him finish the class off. Because I got to use this soda can real quick. It's empty. I'll let you guys figure out what I need to do. So using at dynamic name, and then I provide my own getter and my own setter. Why is this of value to me? Because I still get the property mentality that is available. I get the syntactical sugar that comes from properties, where I have the ability externally of saying we're going to, let's say I instantiate this class and it's called person, and I can say person.name equals. That dot name is, again, that's syntactical sugar, a layer that's placed on top of the actual messaging to the method for the getter. That was a mouthful. Okay, so anyways, dynamic, in case you see it, that's what's going on. And yes, Jonathan, that is what she said. So next thing we're going to do, that's what she said dynamic was. Yes. So anyways, let's talk about some of the different property attributes that we can use.
This is awesome.
I'm trying to keep my composure, and I'm trying to be careful with looking over in the BuzzNet because...
I know.
Wow, not yet, Nelson. Well, yeah, you can go outside, Nelson. We'll be taking a break in a minute. I'm working here. Jeez. And Jonathan, she did not say that. Continuing on with property, we're going to... oh, he's messing me up. No, on track. So property attributes. Okay. If we wanted to specify our own names, no, moving on from that one. All right, read write. Fine, Jonathan, then you can come in here with, you can say getter equals, and you can specify a name. And if you wanted to specify your own name for setter, jeez, I can't believe he's like pressuring me. Then you can use a property for setter. This is way beyond what I wanted to do. I accidentally started right, and look, I shouldn't have even said anything. And then we would specify our name. So this allows us to go in there and again, using either of these two attributes to specify our own name for what we're going to be using for a getter or for a setter or for both. Next, read write. All right, now this is getting into what I think is important because this is what we're going to be using this one. So read write or read only. Okay, so in this case right here, our default is going to be read write. So if we don't specify anything, obviously the property is going to generate a getter and a setter that is going to allow us to set the value, and it is going to allow us to read the value. Often you're going to find that I like overriding that with read only. That's really important to me. Again, back to the concept of encapsulation. You should not let external objects manipulate directly data members inside a different class. Okay, so our default is read write. So this is the big D. But you'll find, which means you don't have to specify anything, and it'll just be the default. Though you can specify it if you want to be very verbose for anyone who comes in and looks at the code later and perhaps doesn't know anything. But for me, but read only, of course, you're going to have to specify because that's not the default. So let's go ahead and undo that. Okay, so let's see another one that I want to talk about. Assign, retain, or copy. Assign is going to be our default. Just think of equals. Mr. Terry did an awesome job along with a couple other of you guys, Pencil and I think there was one other that earlier had, when I had said, all right, for this setter, how are we going to do it? And you just simply said name equals new name. That is assign. It's just equals. Retain. Well, we all know what retain does. That's simply going to stake ownership. It's going to increase the retain count of this object on the heap. And then we have copy. We're not going to be using copy tonight with what we're doing, but copy is an important one. There are cases where instead of retaining the object, you want to get your own copy, especially when we start getting into security issues, where you want to make sure that something cannot be manipulated whatsoever. Let's say I wanted to get a copy of an array that's in a very particular state. If I just used assign, I still don't get what assign is used for. Well, if you didn't need to hold a reference for it, for whatever reason, and there are reasons, but for whatever reason, that would be the default. But retain is an enhanced, and just for those of you in the future watching this, we had the question, does retain include assign? Yes. Retain is kind of like super assign. It's like we're going to assign, meaning use the equals, the assignment operator, but we're also going to make sure we retain it as well. But back to what I was getting at just a moment ago, with copy, what if we had an NSMutableArray or even just an NS array, period? So a collection of some sort. That's a better way to put it. We have a collection of data, and I want to make sure that collection does not get manipulated externally. And let us say that there is a possibility it could be manipulated externally, but that would be bad. that would be a case where we would copy it. So by copying it, we now have our own completely private and protected copy of that collection in this particular case. And I'm trying to be careful with how I'm talking about copy at the moment, because that's going to become a lot more pertinent and easy for me to explain. No, it's not a copy of the pointer. It is a copy of the data. It is a whole new object, and that gets into a whole bunch of new stuff. That's why I'm just trying to be careful, but I want to make you aware that it's out there and what it is. And it's something that we will be using when we get over into iPhone development. But for tonight, everything that we're going to be doing is just rather going to be a straight out assign, or we're going to be retaining it. Now, you guys already saw when we were using NSInteger, being a value type, we didn't specify anything. We could have specified assign, but assign is the default type. So that's already in place. We couldn't retain it anyways because it was a value type and it would give us an actual error. Okay, so now what I want for us to do is to, so that's that. Default is assign. Let me think. Oh yeah, of course we need to look at this one. Atomic and non-atomic. I don't think this will be important even in iPhone 1 as far as actual atomic goes. Using it. Atomic is the default. And what atomic tells the, well, apologies for the stuttering while I'm thinking here. Here's what I want to show you guys. We have an object that's sitting down here on the heap, and it has a getter and a setter in it. And we have two threads that are running. And two threads are both holding a reference to this guy. So this object is in the middle of, let's say, using a getter. While in here, this other thread could actually get a time slice that will have code manipulated in here prior to this thread's completion of this getter. And so what happens is your data becomes unreliable. And this is a nasty problem to run into. So let's say you've got some logic in here. Let's say your value was set to one thing. So here's the value that the getter and setter is referencing. So let's say the value starts out at one way right here, but this other thread causes an interruption, and then that value is changed to something else. So let's draw it this way. And then this thread continues with its execution and finishes this method. So I'm drawing it horizontally and vertically to represent the data is now different. So you'll notice what ended up happening is the data was changed before thread number one's execution of the getter was completed. And that's bad. Oh, it does look like a face. That's cute. Hopefully you guys can see that this would be bad, okay? So by allowing properties to be atomic by default, what happens is the compiler is going to generate the code required to make sure that our objects are properly locked and protected so that the value that starts when a thread's execution begins, it owns this all the way through to the end. So it starts by looking like this and it ends by looking like this. So that is what atomic means. But here's the deal. That's extra overhead. That's extra overhead that if you are writing an app that's not a multi-threaded application, that's extra overhead that you don't need to have there, okay? That is why when you come in here and you see people creating properties all the time with non-atomic, that is simply telling the compiler, look, we don't care if we're thread safe or not. So don't put the extra supporting code in place when you generate the getter and setter for locking stuff. So hopefully that's a good enough of a description. I know some of you may not even know what the heck threads are, but the concept being we want to make sure that we're protecting our data so the data is good from start to finish. That's atomic. Extra overhead, we don't need it. We're not writing a multi-threaded application where we're spooling off multiple threads, and those multiple threads are all referencing this object and could be interacting all at the same time. So that's what's going on there. So by default, it's atomic. Out of habit, just from my old days when writing iPhone apps, I always just used non-atomic unless there was an actual reason for using an actual atomic, which is the default because you have a multi-threaded application. Okay, so atomic and non-atomic, and yeah, there you go. So tonight, you're going to be seeing non-atomic, you're going to be seeing retain, and you're going to be seeing read-only. These are going to be the guys that I will be using. So using properties, you've already seen that we need to make sure that we simply synthesize those guys, which is straightforward. And yeah, with that, I think we're just about up to the point of taking a break. Let's see, anything else that I want to talk about in regards to properties real quick? Nope. That's everything for us to be using these like a madman. Just the big thing for this course, because I've already gone way beyond what was planned for the course. Just remember this. By using properties, it allows me to, one, get access to dot notation. I really like dot notation. Two, it allows me to provide a controlled means of external objects accessing my data members. And finally, it allows me to have code auto-generate it for me by using properties, so I don't have to do as much typing. We just have to provide property attributes to give the compiler some instructions for how to go about handling the generation when it goes to synthesize the actual properties themselves. So with that, let us go ahead and take a break. And we'll come back from the break and we will continue writing our program, because now we'll be able to jump back over into lots of coding as I have done lots of lecture that needed to be taught. So we're now officially on break and I am pausing video. All right, welcome back, ladies and gentlemen. So let's go ahead and continue. So now that we've taken a very close look at properties, let's go ahead and jump back over into Xcode. Let's see where we've left off. So everybody's been reset, so you'll be able to click that you are in good shape once you have the following done. So now that we've got iBeverage, next thing we want to do is go ahead and create usage with the beer class. So basically I'm just going to jump over to beer in our header file, and I'm going to tell beer that it needs to, well, it needs to use it, doesn't it? Wouldn't you guys say? Huh? Actually, I think I might be able to demonstrate something right now. I should be able to without any problem at all. I do want to show this real quick because I had mentioned it. All right, so back to protocol talk. Remember how we had mentioned with protocols, basically you use the @protocol compiler directive, then the protocol identifier, and then you can adopt additional protocols. Check this out. In this particular case, if I come in here and I comment out the adoption of the NSObject protocol and save and do a build, are we actually not going to get, until I use it, any warnings? Oh, I figured it would at least give me a warning. All right, well, it'll give me a warning in a few minutes. I'll have to come back to it. I guess I need to I have to use it first because no code's been synthesized.
Well, poo.
That's all good.
You know how many times that happens to me where I'm like, oh, this is going to cause an error because it's a really stupid thing to do. Oh, it doesn't cause an error. well, you still shouldn't do it because it's
I
done.
was expecting this one actually not because it'll actually build once we get to the proper place, but it's not going to. It'll have warnings, but and we never want warnings as far as I'm concerned. That's an error. So all right. So anyways, let's go ahead and jump over into our beer, and for the beer we need to go ahead and let's see. Looking over here, trying to find some notes so I don't just start making stuff up, which I guess I might just have to do. So let's jump back over to the header file. Let's go ahead and adopt this protocol. So we want to use the, and of course to use it we need to make sure that we import it. So iBeverage, and let's come up here and import iBeverage header. And so all is good there. Okay, so inside of our beer header file, I don't think there's anything else really important. Looking over in BuzzNet, Jonathan said, so no init method. No, we've already got an init that we can override. It's part of NSObject. But what we did not have was the init with temperature. So that's that one we needed to have in place to make sure it's available on all of these different guys. Wait, no, I mean if you comment out NSObject, if it would throw a warning. It's not an inheriting thing. I'll get back to it once everything's in place and I can actually show it given the warning, and you'll see what the warning is and why. So all right, so continuing on. So with beer, there's nothing else in here that we need to actually put. But we can go ahead and start implementing stuff now. So let's do that. Let's come over here to our implementation file. And now so go ahead and reset. So MMO Dust, who got all sorts of excited, went ahead and clicked already. So be careful there. So continuing on with this, we have some things we need to synthesize. And this allows me to discuss something else that's really cool. And that is with beer. Wait a minute. Looking back over there at Jonathan, said, no, I mean you commented out NSObject, throwing a warning because you aren't inheriting. Hang on now. Let's go back up here. Make sure you have a good understanding of this. Beer is inheriting from NSObject. Oh, okie dokie. All right, so yes, it is inheriting.
What he said before.
Exactly. So back over here. But again, this gives me one more cool thing to point out, and that is with older versions of the 32-bit version of OS X and older versions of OS X 64, I think prior to 10.7, I'm not 100% sure though, so don't quote me on that. You had to actually put your hang on. That's because, yes, Jonathan, that's because I was actually giving a point value. But you have to actually create your instanced data member. So newer versions, it won't with the 64-bit 32-bit version OS X. You have to actually create your instanced variables when doing properties. But with iOS and with 64-bit modern runtime, you do not have to explicitly create them. If the compiler sees that you are simply doing at property and then whatever it is, but you don't have a data member, it'll synthesize the data member for you automatically.
He says he's giving you a hard time.
I know he
gets
is.
He gets a demerit.
He gets two. Hi, Saturn.
Ashley's here.
So,
yay.
I just wanted to point that out in case you guys start wondering where our data members about to be coming from, because if you remember back over here in our iBeverage, we've got all of these properties that are sitting there available for us that we need to do something with. So I'm going to save time, so I'm not going too fast. I'm going to copy all of these. So for those of you that are following along, which is everybody, good.
That's right.
Good. Again, I am on the iBeverage protocol, the header file. I copied all of my properties and my prototyped methods, And now what I'm going to do is jump back over into my beer class, which is responsible for adopting that protocol, so for implementing everything in it. And what I'm going to do is I'm just going to paste for the sake of time. So pasting all of this in here, of course, I get warnings galore. First thing I need to do is change all of these properties over to just synthesize. And let me get that space out of there. And now I'm going to grab all of these guys and paste again, just for the sake of speed. Boom.
Because speed is
and
good.
Let's not accidentally kill that guy. And then what I need to do is come over here and at least skeleton in the start of my implementation for my methods. Like such. All right. Now, of course, I'm still going to have some little warnings in there for guys that want to return things and stuff like that. But this is what we're trying to get set up real quick. And since I want to start coding as well, let's go ahead and implement. So I'm going to go ahead and implement my own default initializer. So we'll override init, and we'll simply say that we're going to be returning, and then we'll send a message to ourself, and we'll call the designated guy, which will be the init with temp, and we'll say, all right, all alcohol that comes into existence, or all beer in this particular case, will come in with a temperature of 85 degrees. That's some pretty warm beer. And it's like smoking. Okay, so that will be our simple init. And now let's go ahead and do our init with temp. And with that, this is where we need to make sure that we apply the rules that we have already talked about in the past about doing initialization, and that is we need to go ahead and make sure that we call the super classes init, and it will hand us back rather nil some other object or ourself, and it should be handing us back ourself, and we'll simply verify that yes, it did indeed hand it back to ourself. And if it was ourself, then we can come in here and do a couple things, such as, remember how we have name? Well, I can just access name directly, and I can say that name is equal to, in this case, it's going to be beer, so I'm going to say at beer. And then we have a blood alcohol content modifier property that is required. And with the blood alcohol content modifier, that is going to be this particular beverage's effect once consumed on your blood alcohol content levels. So I'll just come in here and say that our back modifier is equal to 0.02 F, because it's a float.
Oh, okay.
And then finally, we have our temperature available to us, and we'll actually set it to temp that we passed in with this initializer right here. And then finally, Jonathan, what do I need to do? And we'll let Jonathan answer this real quick while everyone else is jotting this code down.
Tell us, Jonathan.
Since Jonathan is multitasking, we need to return it. You could have actually just said how to return it, but we'll just pretend he doesn't know how to do it, so we'll say return self. All right, so
yeah, that.
So now that we've got this in place, this is what is needed for getting our beer properly initialized with a temperature, and we also have a default as well, temperature with a default constructor. So next thing I want to implement is going to be consume, and this really, there's nothing fancy that's going on here at all with the program we're making tonight, but we want the flexibility for later extension to be in place. So that's why is consumed available and consume is available. So right now we're just going to say if consume is called upon, we're just simply going to say is consumed is equal to true. Simple enough. And then that brings us down to our modify temperature. So in this case, it's just a matter of simply saying that our temperature F is going to be plus equal to whatever temperature we tell it to modify. So is there anything else, Jonathan, that I need to add into this? So Jonathan wants to see the protocol. I'll bring that up in just 1 second. But I do want to ask, is this everything? Did I set this up properly, or based off of things that we talked about in class, did we have a problem? So let me go ahead and bring up the protocol real quick. Never mind, Jonathan actually did get it. Good. Don't you need to retain release? Retain? No. Because if you recall, let's jump back over to the iBeverage protocol. We said that the name is going to be retained, and everybody else is just value types, so they don't need to be retained. But we did take care of the retain, so that means you are right about needing to do a release, though. Since we are staking ownership to a name that comes in, let's go ahead and jump back over into our beer implementation, and we'll throw the final piece in there, which is going to be void, and we're going to be overriding dealloc. And then inside here, I want to make sure that we tell our name to release, and we make sure that we call supers dealloc so we don't call up or blow up the entire world.
Typo.
And let me fix my super typo. It's a super typo. So let me go ahead and Command S to save. I'm going to pause the recording. Okay, we're now resuming, and this awesome class of people that we have in here is all caught up and doing excellent. So the next thing that we want to do is take a look at the who's going to be using iBeverage. I mean, after all, we don't want to tie ourselves to beer, as you guys already know. So we've got people that are going to be using it. Who's going to use it? We talked about this, so quick, type it out over there. Who's going to use it? Yes, indeed. All right, so person's going to need to use it.
Wouldn't the store need to use it?
So if we jump over here into person, so person needs to know about iBeverage. We don't need to implement or adopt him, for the simple fact that he just needs to be aware. Because we're going to be telling our person to consume beverages. I don't want to lock him in, as I've been saying all throughout the night, to we want him to consume beer. Of course, Nelson would be fine with that, because I can live off beer. That'd be his idea, right?
I would cry.
Until the moment I told him that, well, here's some JD or some Hunter, which he loves to death. But if we coded it for beer only, he's in trouble. So we know that person's going to need to use it. And I'm just going to do a Command C to go ahead and copy. You guys might want to do the same just to be speedy here. So as Nina just said, the store. So let's jump over into the header for the store. Again, the store needs to be aware of beverages. And good job, Jonathan. Absolutely, we need to make sure that the fridge is also aware. So I'm just kind of giving you guys an idea of, again, how we can take from concept, where we sketched out the overview of the program, and now how it starts coming together as we just start layering code on top of one another. In fact, we're at a point right now where beer is actually finished.
Yay!
So the next thing that I want to do is, here's an easy one that we could just knock out real quick. How about the environment? The environment's very simple. We had stated earlier, the only thing the environment's going to need to keep track of is just time. It's going to be simulatable. So we could jump over and knock out the environment real quick. So let's go ahead and do that. So I'm going to do a, oh, and by the way, just in case you guys aren't, make sure that you do a Command B from time to time to make sure that you get build succeeded, just so that you don't code in a whole bunch of stuff and blow yourself up.
Don't blow yourself up.
And yes, Jonathan, Simulatable contains simply one thing, which is going to be simulate. And we're about to actually make use of that. So let's go ahead and do a Command N, and we're going to create an actual Objective-C class. Let's hit Enter, and this is going to be our environment, which I already made, so I'm going to hit Cancel. Thought I got ahead of myself there. So that's right, we've already got this guy all set up and everything. Yep, complete brain fart. So let's go ahead and jump over to the header file. And inside our header file, there's only one thing that I need to add in here. I said that I want to keep track of time, so I'm going to add a let's add a data member for NS, an unsigned int, and let's just call it time. And I'm going to make this guy very easy to access by setting up a property for him. And the attributes that I'm going to give on this guy is going to be read-only, because I don't want anyone else mucking around with time.
That's
Otherwise,
right.
We've enabled a form of time travel. And again, just out of habit, we're going to say non-atomic. And again, we simply come in here and we give the type and the time, or the name. And one final thing that I want to put on this is going to be a prototype for an init with time. I want to be able to create an environment and hand it a starting time. And then we can do the same thing that we did with the beer. If we wanted to just instantiate an environment, we could have it default to a time. So we'll quickly come in here and prototype out this guy with ID and init with time. And this guy will take a NS unsigned integer, and it will just be new time, like such. All right. So go ahead and make sure that you have this in place. My typing is absolutely wretched when having to use the configuration, which I posted a picture of it a while back on on Facebook. With I'm going to take another picture right now, just because it's funny. I'm sorry, I'm so easily entertained. Also, go ahead, Nelson, and hit the reset button for me so that people can hit that they're caught up when they're all done. And since I figured that we are in pretty good shape, I'll go ahead and I just have to. Quick picture from way back here. Oh, so many monitors. So much awesomeness. Okay. So I assume Nelson hit reset. I never saw him hit reset. I didn't think he did. I don't even think Nelson's listening anymore. All right, go ahead and very good, sir. And very good, sir. Very good, sir. And Jonathan, come on. I'm just kidding. Very good, sir. And we're almost there. Outstanding. Good job. You guys are all rocking. So now let's go ahead and move ourselves over to our implementation of the environment. Let's just knock it out with everything except for simulate. So what I'm going to do, again, I always do this just to speed me up. I'm going to Command-C and grab my property and my init with time. So highlight and copy. And then let's go ahead and jump over into our environment. And then over in the environment, let's go ahead and paste. And let us simply synthesize this guy. And we'll get rid of that. So we'll synthesize time. And then let's go ahead and put that guy in place. So now we've got our property in there. And we've got everything nice and happy. But let's go ahead and start getting our... let's go ahead and start getting everything set up. So we're going to simply override init. And then with init, let me use this keyboard over here. I got like 2 different keyboards with the darn Mac. So I'm going to do the same thing as we did with the beer. We're going to simply say return self, and then we'll call our designated init with time. And we'll simply say if somebody doesn't say what time it is, we're going to say that it's 12 o'clock. So that's going to start. This will be a 24-hour clock.
Oh, I was going to ask you that.
And this is going to start us out at noon. And Rowdy Bull just said that app code is sweet. It took care of all that for me. And I would sure hope that it would take care of all of that stuff since it is the incredible JetBrains people. Okay,
JetBrains.
So now init with time, let's go ahead and do the standard that we always do here, which is going to be if self equals, and then we'll call supers init. Do not ever make the mistake of coming in here and do self right there. That's no good. So self equals self's init. Yeah, that's funny. Anyway, so if all comes back successfully, I'm just going to say time is going to be equal to new time. And then we're going to return self. Okay. I'm not going to worry about simulate at the moment. We're going to implement everybody's simulate after we see that the whole system is functioning perfectly. And if I was actually coding this, what's my mentality behind this? Because this is how I would actually do it for real. Well, I know that I should be able to instantiate a person, a fridge, a store. I should be able to stock the store, and then I should be able to have the person purchase items from the store, put it in their fridge. I should be even able to have the person consume beverages that are in the fridge. So I should be able to do all of that stuff. The only thing I won't be able to have happen will be time advance, and the store have more stock at it, and the temperature for what's in the fridge, those items get cooled down. So those are going to be the things I'm going to be missing out on. That's no big deal. What I want to do is focus on getting the core of the application functioning properly. And then once I know all of that is working, then I'll go back and add the simulation bit to all of the required pieces. Ha ha ha, very good. So Jonathan said, since time has no value assigned to it, you don't have to release it with the initWithTime method, right? Well, of course we don't. It's just the value that's like hanging out. It's like, hi, a low value.
I'm low value.
So just making sure. Okay. So no, that's
correct,
good.
sir.
So now that we have this in place, what I want to do now is let's move on to something more interesting. You guys ready to like amp this up? Let's implement the store, because I'm thinking
I was getting Nelson drunk.
I'm thinking, well, but follow the whole plan out.
I know.
For Nelson to get drunk, he must have beer. But for there to be beer, there must be a place that sells it. So
I'm jumping the gun.
So that's right. It makes sense to me. Let's go ahead and jump over here,
right.
and let's take a look at what we might need over in the store and implement this guy. So, which is going to lead us into a couple of other fun things to discuss. So the store needs to know about, let's see, he knows about beer. How does he know about beer? Because beer is an iBeverage. And beer imports iBeverage already. So we're going to know about it. And we've already got the simulation stuff in place. There's one more thing that I want to do, because we're going to start logging things out in a minute, and that is I want to create our own class with the ability to write stuff out. So let's do that in just a moment. All right, so the store. A few things that we're going to need for the store. So let's go ahead and get these data members set up first. First thing I want to do is I want for a store to be aware of the environment. That means there is something I need to make sure that we go ahead and bring in. We need to bring in our environment. So back to what I was saying. We need an environment, and we'll just do an environment pointer to env. Good enough. And we need, all right, we need inventory. We need a place in which we can store stuff. This is where we're going to be using our first collection. Collection is going to be, yes, it is an array. It is a place that allows us to store multiple objects. Now, when working with NS types, you're going to find lots of types that are immutable types and mutable types. For example, NS string is an immutable type. So if I was to jump back over real quick to the whiteboard and beg and plead for a new blank space.
There is a little one.
And I said something like NS string A equals, and then let's say we had some other string, B. Let's say that B is already defined and is pointing to an NS string object. So now we have A also pointing to that same object. But now if I was to turn around again and said that A is now equal to, and I point to a different string, remember we're dealing with pointers here. So it's not like NS string, because remember, what is A? A is a pointer. So here's our stack. Here's our heap. So here's A. And A right now is pointing to this NS string object. And let's say that it just has the letter X in it, in its textual value, in its text value. And then we have this other NS string. Remember, we had B, is this other guy that was already defined and initialized up here, and it had a K in it. When we say take A and then reassign it to someone else, it's not like we're updating this value inside here. This is an immutable type, so we can't actually go in there and change it. Now, there is an NSMutable string where if we go about changing the content, then we could actually change the content in here. When working with an NS string object, you cannot change this data. The data that's in here is stored, permanent, as far as this object is concerned, because it's an immutable object type. The same thing is going to go for an NS array. So an NS array, arrays are nothing more than a collection. Looking for some place to write.
That's a great theme song.
Oh my goodness, it's out of sight. Here we go.
You rhymed.
Hey, I did. So here's an array. So NS array. And let's say that I created, in this case, 1, 2, 3, 4 different strings. So let's say that I had at A, at B, at C, and at D. And when I created this, so an NS array is an immutable array, meaning when you actually create the array, the objects that you assign into it, you can't expand. The array it's exactly how it is. It's immutable. You can't change it. So if I was to actually create the array, yeah, it's a fixed size, and I was to put objects in it. Let's say that when I actually created it, I said that's going to be our first object. That holds our second object. This holds our third object. And this holds our fourth object. And I just wanted to draw this here, so this will, because this will be coming into play shortly. When going back and looking at an array, when looking at your actual type that's holding this data, you can access the elements inside of it. They're index-based. So index 0, if I was to say object at index 0, what is object at index 0 pointing at? We know it's an NS constant string, a string literal, but what is it? So if we actually looked at the array at object at index 0, this is, think of it like a mailbox address. This is 0, this is index 1, this is index 2, this is index 3. So if I said that we wanted to look at 0, who are we looking at? Look at the pointer, because I mean that's all it is. It's pointing. What is it pointing to?
D.
D. That's what it's pointing to. So if I said look at index 3, what's in index 3?
C.
That's right. Index 3 would be this. What if I wanted to add another object into here?
No.
You can't do that. This is immutable. This is fixed. So what we're going to be focusing on is using an NSMutable array. So with an NSMutable array, I can come in and dynamically have the runtime change its size by adding objects, removing objects, etc. So when creating an NSMutable array, personally, I always like to just create an empty array to begin with, and then I simply start adding objects to it. So when I add my first object, If we said, what's the count? If we said, what's the count up here? Whoops, that was an error. let me fix this. So if I said, what's the count on this array, because that is a method that you can message, what is the count? That's right, Terry, good job. The count is 4. There's 4 elements, so it contains 4. What's the count on my NSMutableArray over here? Right now, the count is 1. So then if I turn around, Terry, the count is 1 because oh, and you may have just missed what I said just a second ago. I said when I add an object, maybe that'll help. So I actually added an object to it. So then if I turn around and add another object to it, I'm now pointing to that other object, and that's at index 1, but what's my count?
2.
My count's 2. So be careful, for those of you that are new to coding, when you start working with the index values for these arrays, it is 0 based. So don't get yourself in trouble with that, because the highest you can access is always going to be the count minus 1. Okay? That's right. As Jonathan just said in BuzzNet, the index and the count don't ever match. So I wanted to point that out. So having seen that, since we've got all sorts of fun coding to do, what I want to do is go ahead and jump back over. So now we know about mutable and immutable. Let's go ahead and Command Tab back into our code. And it's 0 based. Absolutely. Very good, Mr. Rowdy. And let's go ahead and create our first array here. So we're going to do an NSMutable. So let me move some of this junk out of the way. So NSMutableArray. And we'll just call this, of course, it's a pointer, stock. And then I'm just going to make a couple of quick ints. We're going to have an int for our open. And we're going to have an int for our close. So that is the hour in which our store will open and the hour in which our store will close. Now, that's the data members I need this store to have. The next thing I want to do is go ahead and prototype out the public methods that are going to be accessible external of the class. So the very first one that I'm going to put in here is going to be an initializer. I have a very specific need for my initializer. And that is when a store is instantiated, the store must be given an environment and open and closing hours. Okay, it has to have an environment. Nope, does not have to have stock for starting out. It can be empty stock. We can go about populating it with stock in other ways. I will, in the constructor, just throw some stock in there. But the absolute requirements for this guy to function properly is to have an environment. And right now the environment's, it's a simple concept. Right now all it does is it manages time. But if we want to add more to the environment, that is where we would go back and do it, as opposed to like digging through a whole bunch of different classes. So if we don't provide the store with an environment, then we don't want to have a store. So what I'm going to do is, geez, hang on, I'm sorry, no, it's okay. I just got stuff all over the place. My desk is in sad shape. So what I want to do is go ahead and, trying to pick what keyboard I want to type from. ID, let's go ahead and type this out. And we're going to do an init with environment. And we're going to take in an environment, and let's call it new environment. Now we're going to do multiple parameters here. And remember, with the way that, or the convention that Apple sets forth, they want the additional parameters to read in a very friendly way. So init with environment and our open and our opens. Yeah, that sounds good. And our opens is going to take in an int, and we'll just call this open hour. And our closes. And the hour that it closes, again, it's just going to take in a simple int, and we will call this close hour. We'll terminate that. Okay, so the next thing that we want to do, shouldn't the environment be independent of the store? Ew, no, we need to have some sort of coupling that takes place here because the store must know about the environment. It has to know about the environment. I wouldn't want to code it in such a way where suddenly the store can function in a void, in a realm without time. I'm defining that my store will always function in a world in which we will have time. Okay, so, and again, also, and I want to point this out, if I want to go into environment and have, what if we have multiple, what happens if we have multiple stores? They're all going to share the same environment. Okay, good. Just making sure you understood. So that way, though, if I need to change the environment later and add additional things to it to enhance the actual environment, everything's already set up to work with an environment. So, so next thing I want to do is let's go ahead and give ourselves an ability to list the inventory. Did you get good news, Nina?
Yes.
From who?
I'll show you.
Uh-oh. So list inventory. And let's go ahead and do, so now let's do some funky stuff. And so with the, wow, that's interesting.
Isn't that great?
Yes, wow. Okay, so the final thing is we need the ability for someone to purchase. So for purchasing, what they're going to purchase, since we haven't gone as far as, like I was saying earlier, by doing an iProduct, everything is just locked to Beverages for how this whole system has been designed. We won't, any purchase that takes place is going to hand back a what? What is it going to hand back to whoever calls upon the store to purchase? Someone toss that out for me. That's right, an iBeverage. So we talked about when MMO dust. Be careful when you say beverage. I agree with Jonathan here. It needs to be an iBeverage. So the naming becomes very specific at this point. Or Mountain Dew would be mighty tasty right now. So the way that we send this back.
Or an iMargarita.
And oh my gosh. So we're going to say some object that has adopted the iBeverage protocol is what will be returned when we make a purchase. That's horrible, Jonathan. I'll take 2 udders, please.
On the rocks.
I'll take 2 udders on 2 udders on the rocks. Oh, that's horrible. Okay, so this is our implementation for the store, and since Nelson's gone to bed on us, let me go ahead and just reset. For those of you that are following, which is all of you, go ahead and make sure all of this is typed so that we can jump over into the implementation section, and I'm pausing. Resume. All right, we're back. Real quick, I just wanted to point out Matthew had the worst time in the world with spelling, which was completely throwing me off. But he did point out a bug that I just introduced. And that's what happens when trying to monitor for questions, talk, and type all at the same time. Purchase needs to return back an iBeverage, which is exactly what I said, but I actually typed. My fingers did its own thing. So iBeverage.
Darn fingers.
Darn fingers. So for the record, and just so that this is permanently on record for Matthew, thank you very much, Matthew. It's awesome, though, because him and I clashed heads with one another because he just couldn't get his spelling right and I just couldn't get my words right. And with that, we'll go back to pause for those of you that are finishing typing out the code. All right, and we're back.
All right, let's do this.
I would like to thank Mr. Seaby for pointing out one more spelling mistake, and that is I don't know how to spell inventory. I-N-V-E-N-T-T-O-R-Y. Yes, there we go. So, all right, now that we have our implementation complete and everybody in the class has got it all done, let's go ahead and jump over now. So I'm going to hit Command-S and grab our methods here and jump over into our store and get ready for some implementation.
All right.
And again, we're going to be coming back to simulate just a little bit later. So inside of our store, let's go ahead and paste these guys in.
Ashley.
Let's set some stuff up.
Don't worry, Ashley. I've been completely safe in all shoots.
Oh, my goodness.
I love danger,
On the next break, we will go as far. You guys will get a special treat.
Yes.
We'll tell you guys what we've been doing.
Yes.
Okay, so skeletoning these guys in real quick. Now what I want to do is go ahead and handle my init right off the bat. What I'm going to do is I'm going to say that if anybody tries to initialize a store without providing an environment and all, is going to be, and open and closing hours, then I'm just going to, now I really want to get I just want to print out, and I'll come in here and actually use this in a few minutes. You must supply an environment. And let's go ahead and, yeah, we'll do that. And then I'm going to return. Take a guess what I'm going to return. Nil? Yes, you're absolutely right. So let's go ahead and return nil. So this is a scenario where we could actually go about initializing an object, but get a nil back. Now remember, the cool thing is, if let's say we completely screwed up and we didn't check to make sure it wasn't nil, and we start deciding to call messages on the store, what happens? Tell me what happens. So I said I want to alloc and init a store. Bad stuff. Matthew, of all people, I expected you to get it right. Matthew. And Jonathan's like, I don't know, I'm just keeping my mouth shut. It's all good. And Rowdy knows. He's just teasing. Same as Saturn. If I get a nil back, stop watching TV. So just remember, anytime I had pointed this out before, anytime you call a message on a pointer that is pointing to nil, it's a no-op. That's one of the things I absolutely love about Objective-C. It's not an error. So no worries, Rowdy. So that's right, Jonathan. Nothing happens. So if we forget to check to see if it was nil, I mean, obviously we would want to, and then simply say, blah, blah, blah. But if we progress forward, we'll just notice our program's not working. I mean, we'll notice quickly, because we'll be like, hey, man, let's go make a purchase from the store. Why didn't I purchase anything? Let's add some stuff to the store. Why didn't I add anything? Where's the store? And then you look at it in the debugger, because you're all cool like that. You're like, oh, my God, the store is pointing to nothing. This is not cool. And then you're like, oh, yeah, well, what do you know? I screwed up. Well, not to mention, it's also going to print out an error. I'm having it say you must supply an environment, as kind of like a clue. So that's important. So I do want to jump in here real quick, and I want to make a log class. So help me out here. How do we do this? We're going to do a command in, right? Good. Jonathan, you're all over it. And then MMO Dust just redeemed himself by saying hit next with making an Objective-C class, and we're just going to call this log. Okay. So next, enter. So now we have the buzz log. That's right. So now we have a log. And the first thing that I'm going to do in my header file is I'm going to come in here, and I'm going to, and this is going to lead its way towards some of the multi-tiered homework that's coming a little bit later. I'm going to do an import. And what I want to do is import the std.io, the standard IO. Thank you. My fingers are just not working tonight. So that I have the ability to do printf. And then I need to set up a method that allows anyone to call upon this object to print out some text. But I don't want them to instantiate it. How do I do it? Tell me. All right, good. So Jonathan and Matthew both said we're going to use a plus. That's right. We're going to use a class level method. So with a class method that returns void because we have no return type. And here's how I'm going to name this. Remember, since we are messaging this guy, it would read best if I simply called the method text. Instead of saying print to log, because that, for those of you that can't see, that is what was just sent in. I know this has got an error at the moment, but I just want to show this. I don't want to call it like this. I don't want to say log and then say print to log. Blah, blah, blah. I just want to keep it simply and say log text and give it some text to print out. I'm just keeping this nice and easy. And yes, the other one is super verbose for the record. But like I said, I'm going to keep it nice and easy because I'm like that. So what does text need to take anything in? Yes, it does. As MMO said, it needs to take in a string. Here I am looking and copying your stuff. An NS string pointer. And it's going to bring in our text. So now let's go ahead and jump over and implement this guy. And with him, we're simply going to say, you guys remember how this goes? I'm going to do a printf, and then you want these little cute things. And then you want to do like maybe I want to print out a string, and I'm waiting for someone to like jump in. I'll slowly keep typing. And then it's like, well, what's the string that you want to do in there? And you guys are saying percent that, and Jonathan's saying percent that. So let's ignore Jonathan for a moment and say we're going to take the text that's coming in and we're going to call a message on that text, and it is going to be C string using encoding because we're converting this over from an NS string over into, yeah, my bad. And we're going to use NS UTF-8, and we're going to use UTF-8 string encoding. Nice. There you guys go.
Yay.
And this is important. Later, it's going to become a lot more important with part of a homework assignment that you guys are going to have. Again, an optional homework assignment that is being designed just for my good friend, Mr. Rowdy, and for those of you that want the challenge and want to improve your skills. You will be revisiting log. So let's go ahead now and jump back over into our store. And in the store, I want to make sure that we are using the log. And so now back over here where we said print something out, now let's go ahead and do a, let's say we're going to do a log. Sorry, I looked over at what MMO Dust was just saying. And then we're going to do text. And then what is that text going to be? Well, I already typed it all out, so I'm just going to like, whoops, one too far.
Oh, no.
This guy, this guy, this guy. There we go. So now we have an easy way every place to do a printf without doing tons and tons of stuff. So let's go ahead and do a quick build and make sure I don't have any problems. Of course, I'm going to have warnings because we aren't returning stuff. Using NS UTF-8 encoding, Mr. Rowdy. And back over here in, we just had, who was saying, was it MMO Dust was saying, oh, okay, he said, I don't think. I was just about to show you that it won't work. But Matthew's right. Percent and the @ symbol will not work with printf. It's printf has to use our format specifiers that are, standard C library printf format C specifiers. So this should have us all nice and groovy. Jumping back over here into the store. So now we have the ability to log stuff out. I like it. The next thing I want us to do is let's go ahead and take care of getting our init with environment in place. So for that, let's do the same old if self equals. And I'm going to call super. Call super's init. Thank you. And then let's go ahead and make sure that we return self. And then jumping inside here, I'm just going to take my hour open and set it equal to open hour. You love my crazy naming here. My hour close, set it to my close hour. Then I'm going to take my, we need to make sure that we bring that array to life, don't we? Back here in the header, I said that we're going to have an NSMutable array. But this is basically said, okay, on the stack, we're going to have a data member, a variable that is going to be pointing to a section of memory. Oh, it's right now, yeah, right now, what we need to do is allocate this guy so he's not just nil. We need to come in here and create him. So what I'm going to do is come in here and tell it to have everything allocated and set up. There's all sorts of ways to create NS arrays and NSMutable arrays. Here's how I'm going to do it, the way that I generally prefer when working with mutable arrays, and that is by saying we're going to take stock and set him equal to an NSMutableArray array. And see, you've got with capacity and with objects and all sorts of stuff. I'm just going to do that.
Do it.
So this is, you can do it with alloc and init, and again, there's a lot of different ways. Now, memory time. I like this sets up and creates an empty array, an empty NSMutable array that has been added to the auto release pool. Let's make sure we grasp the incredible significance of that. I don't have to manage this guy. That's important to me. Anytime I can get away with working with objects in such a way that I get an auto-released object back, this is the way I prefer to do it. If you start using alloc, along with a few others, then you're going to get yourself into a situation where you then need to make sure that you start worrying about releasing, retaining, all that fun stuff. But by doing it this way, I don't have to worry about releasing stock. It's going to take care of itself as soon as the program itself ends, because right now, all of this is going to take place from main. That's where all these things get instantiated from. And since I haven't specified an actual, I'll get to that in just 1 second, C-by. Since I haven't specified an auto-release pool that we're working inside of at this point, then we're going to go into the only auto-release pool that we are in from this guy's point of view, and that is the one that is inside of main. So once the program ends, we'll get a release sent to this guy, and his retains at 1, it'll automatically be released down to 0. So now let's go ahead and, and as for the hang on 1 second. No, this would be weak. As for the looking at the question, C-by says, how do you know when we need to use alloc? In most cases, when instantiating NS objects, I try to always use an init with as opposed to using an alloc. Okay? For the simple fact that, again, once you're using alloc, or if you use new, or if you use copy, there's a handful of different things that you can use that will result in the generation of your object that requires memory management. In this case right here, this is going to be taken care of, since it doesn't have alloc or copy or new being used. This guy is going to be an auto-released NSMutableArray, and that's what I want. to make sure that I don't have to worry about setting up a dealloc, retaining, releasing, and all that fun stuff. All right, so now that I've got my stock set up and properly initialized, next thing I want to do is add some stuff to it. So to add some stuff to it, we need beer. So if we come over here, how much of beer did we put in place? We got init with temp. Oh yeah, beer was done. So let's put some stuff in our inventory just so that we can, and I'm just going to cram it right in here for the sake of simplicity. So here's how we actually put objects into our NSMutableArray. We call upon our array, and then we say add object, and then we give it an ID. Now here is a case where we're going to be using alloc. So I'm going to come in here, and I'm going to say that what we're going to do is do beer, and did I not? Back over here to store. Store is using
iBeverage.
Back over here.
Why is it mad?
Well, there we go. Alloc. Init with, hang on a second. Am I actually going to be forced to, surely it is not just that late right now. Making sure I don't have anything else spelled wrong. Let me quickly jump in here and import my beer.
Imported beer.
Yeah, the best kind.
No pun intended.
Come back over here. There we go. I guess it's just with, thinking. Oh, all right. Well, hang on. Brain is, I could have sworn I just did this with the one. But anyways, let me continue forward. All right, so it's now aware of beer anyway. So let's go ahead and alloc and bring it in with a temperature, and we'll bring it in at, we'll just do the default of what it had anyways at 85. And then I'm just going to copy this line, and we'll add several, but let me fix the typo real quick since it is a message call to stock. No, I know, Jonathan. My brain is clearing up. Let's go ahead and bring in a handful of these guys. So actually, let's give it a few more since we want Nelson to get toasty without having to worry about actually no such things as circular references. Be careful. We're using imports here, not ha. So anyways, continuing on. So we're just going to bring in a whole bunch of beers. And then the last thing I want to do, is there anything else that you guys can think of that I want to do here? Return self. I've already got return self. Okay, so I'll help you out. We also have the environment that's being coming in. So I want to make sure that, remember, that was kind of the key thing. We wanted to get this with an actual environment. So what I'm going to do is I'm going to say, we're going to take this new environment and we're going to retain it. Because remember, somebody else is passing it in, which means somebody else could release it. So I want to stake ownership. And then what I want to do is come in here and set it. So I'm going to say that this guy is going to be equal to my new environment.
Yay.
So getting that set up. But that means what, guys? What do I need to do? Give it to me quickly. That's right. Very good, Matthew. If I'm going to own it, I better get rid of it. So I'm going to go ahead and quickly override dealloc.
Or you'll have a memory leak, right? If you don't.
Yeah. Or, well, more importantly, we'll have a, in this case right here, I was starting to think of if it was over-released somewhere else. But yeah, we'll end up with a memory leak if we don't go in here and clean it up since we staked ownership in it and upped its retain count. So let's go ahead and tell it that we're going to release it and call supers dealloc. Okay. So that takes care of that, takes care of getting beer in. And let me go ahead and do a Command B. And everything is building good. We've only got one warning left, and that is going to be our purchasing. So our inventory, we know now that our mutable array is getting created. We know that we have a whole bunch of stuff that is being added into there. So now what happens if somebody wants to get a list of that inventory to see, what's inside it? How can we go about taking a look at that? Well, it's actually pretty easy. What we're going to want to do is use what's called fast enumeration. It's a special for loop that will quickly allow us to walk through all of the objects inside and pull them out so that we can touch them. Exactly. So I'm going to do an NS string. Here's something else you're about to see me do often. An NS string is immutable. This does not need to be mutable with any additional overhead. What we're going to do is just quickly set up a txt, and we're going to say that it's equal to an NS string, and I'm going to do a string with format, and then I'm going to tell this guy, all right, everything that I write out to the console, and this is going to be really important for homework a little bit later, so pay very close attention here. Everything that gets written out from this system, the store, the person, the beer, anybody, to the console, needs to designate who it actually was that sent it out, that wrote it out. So this is the store that is going to be writing out to the console. So what I'm going to do is for everything that I'm going to send out is I'm always going to have a space to start just to kind of push it off the edge. And then just inside of square brackets, I'm going to say store in this case, and then close off my square brackets. Again, this is just a formatting convention that's going to be followed throughout this app so that you can see messages coming from the system. And I'm going to do 2 dashes. And then I'm going to say store inventory. And here is why I did string with format. It's because I'm wanting to actually have this string put together with a piece of dynamic information. And that dynamic information is going to be the count, which is going to be changing as inventory changes. So what I'm going to do is tell it that we're going to use Jonathan's good old percent here, but we'll do LD. And now I need to give it a comma. And we're going to say what? I want to say how much is in the store right now, what the count is going to be. So we can actually come in here and so say store inventory, and to make it even more verbose, we could say total count equals, and then have the number actually print out in there. And I'll go ahead and new line it as well. And very good, Matthew. And what we want to do is we want to do a message to stock and tell stock we want his count. Okay? And then we want to make sure that we close this guy off. So now we have a properly formatted string that we can then turn around and we could say log. What we're going to do is send you some text. We're going to send you that text, except not like that. Okay? So that's going to now tell us how much we actually have in there, but now we need to loop through our array and actually show what's in there. So let's go ahead and do that. So I'm going to do for, and generally we've got the for-for statement. And this is what I was talking about a second ago, how we have fast enumeration. So this is another new one that we haven't used before. But this will allow us to say for in. So I'll go ahead and use the code snippet, put that down. And so we have to start out by saying our type and then give it an identifier that we could then work with inside the for statement. So the type here is going to be what? What kind of stock are we keeping in an NSMutableArray? Oh, and I guess I need to throw this out there real quick for those of you that are aware of generics. You guys are right. For those of you that are used to generics when dealing with NS arrays and NSMutableArrays, there is no concept of generics. you can put any object type in there, okay? So I'm going to tell it here that what we're looking for is, remember, ID. So you guys were right, but this is what I was hoping you'd say. It's ID iBeverage. And now that we've given it the type, now we just need to say what we want to actually call it. So I'll just say Bev. Now in what collection? It's going to be in our stock collection. And now for our statements, what do we want to do as we loop through it? I'm just going to come in here and TXT is still available. And so let's just go ahead and repoint it to a new NS string. So we'll do NS string. And again, we'll do string with format. And then this is going to be another message coming from who? The store. And then we'll just simply say beverage and whatever their name is. And whoops. So percent such and such. And of course, we'll do a new line. And then we'll come in here. And now I can say beverage space name, like such. And now that we have assembled the string, let's just go ahead and do the same thing we did a second ago, which is not type a whole bunch of stuff like that, but simply do a log and all right. And I'm like trying not to choke here. We're about to take a break in a minute because I do need to like try to cough up whatever's like making me die.
You swallowed the fly.
So this has a
I can tell your voice is going.
I know, and it's because it's like a popcorn kernel that
Oh, no.
I've got. I'm trying to swallow, Jonathan, and I know you want me to stop, but I've got to get this thing released.
Oh, Jonathan.
So anyways, so this allows us to simply walk through and print out our inventory. So let's take a look over there. We've got Terry says can't get 4 to show up. Ooh, really?
Uh-oh.
That's interesting. So when you start typing out 4, well, let's go ahead and do this. I will.
Got it.
Okay, good. All right, excellent. So that gets everything in place for creating a store, for adding beer into our inventory. And yes, this is basically a for each for those of you from other languages that are familiar with for eaches. And this also allows us to list out our inventory now. And then for purchasing now, purchasing is a little bit more fun because we need to check to see if the store is opened.
Ah, okay.
And if the store is indeed open, we then need to go in and make sure that we have stock. So let's just do it like this because I see Nina sitting here going, oh. So is it open? Is store open? So that's important. Do we have something to sell? I mean, you can't let them purchase something if they don't have something to sell.
I'm excited because I'm remembering all the if and then.
Awesome.
Yay!
And then if we do have something to sell, then what we need to do is sell it to them. But that's a little bit involved. So, oh yes, look at this. That's a really good point out. And this is just from, this is a convention mistake. Thank you, Jonathan. That is something that loves to just hang out with me because I've done much more coding in C# than I have in Objective-C by a long shot. And the convention from Microsoft is having all of your methods begin capitalized.
Oh,
so in this case, but I can just simply right-click on this guy, come up here to refactor, and tell it to rename, and change purchase from large to small. And then let's go ahead and rename, and yeah, go ahead and save it out, and now I'm not worried about doing a snapshot. All right, done. So I don't know what you're talking about. So
it was like that all the time.
And yeah, and as MMO Dust just pointed out, he said, which is the right way, and I concur. Now, when we go to sell the item to the person, this is a little bit more involved because selling the item means that we need to actually remove it.
Gotta take it from the inventory.
And then give it back to the caller or the messenger or the message caller. So, and in doing that, we're going to have a little bit of fun with memory, something that kind of confuses people. So this is what we need to
unwind the stack.
So this is, well, after the call, it'll,
Yep.
So anyways, continuing on. So what we need to do is first check to see if the store is open. And that's going to be really straightforward. We'll just simply come in here and say that if and we're going to send a message to the environment's time, and we'll say if the environment's time is less than or equal to our hour open, and the environment time is greater than or equal to our hour close, then what we need to do is send a log out to text that says, store is the sender of this, we're closed, go away, and a new line.
We're angry store owners.
Now, the most important thing here, we need to return nil. Remember, this guy is returning back an iBeverage. We want to make sure that in this particular case, we don't return anything back because the darn store was closed, so they didn't purchase anything. So there's nothing to send back. Okay?
Oh, boy.
Should it be other not? So let's see, 24-hour time. So if it closes at, I told you guys, I'm tired right now. I've been talking for hours. So if it is between the 2 hours, yeah.
Wait.
If we're between the 2 hours. I have it right. You're making me question my own logic. Ah! So moving on.
He was testing you.
Yeah, that's all it was. So next, Matthew's sitting there scratching his head. Do we have something to sell now? So this is real easy. All we need to do is come in here and say if, and take a look at our stock. If our stocks count is equal to 0. There's no reason to say less than or equal to 0 because let me tell you, if we're less than 0 in an array, we've got a problem. So if it's equal to 0, then we're going to have the same thing. We're basically going to call log, and we're going to send a message out saying that our store saying we have nothing to sell. Go away.
Get off my lawn.
And then you can just come back later when they have inventory. And again, we'll return nil. So, next thing. Let us go ahead and sell it to them. So we need to first start out by removing it from the inventory. Well, I'm actually going to start out by grabbing the beverage out. So I'm going to do a temporary ID, and we'll do an iBeverage. And then we're going to grab we'll just call it beverage, is equal to, and then I'm going to simply grab out in this case I want to grab out the last object. So we'll come in and talk to I'm sorry, hang on, this is just, my phone was, that my son was trying to get a hold of me. We're about to go on break in just a minute, and then I'll take a look at that. So anyways, so let's go ahead and, so our beverage is going to pull out from the stock our last object. So what I'm going to do is I'm going to grab last object, but I'm going to do something tricky here. I'm going to retain it. and here's why. So let's take a close look at this. When we add stuff into the array handles staking claim itself. So by adding in a beer into our stock, the stock itself calls a retain. When the beer is then released, or I'm sorry, removed, it causes a release to occur. Because of that, anytime you want to put stuff into an array and then pull it back out, you don't have to worry about retain and release because the array is going to manage that for you. But it's what's taking place on the outside that becomes important. We are about to return this beverage. Okay? So think about this. We're about to return the beverage back to somebody. If we simply pulled the beverage out and removed it, when we created the beverages up here, we didn't do a retain on these guys. So we just simply relied on stock, the NSMutableArray, handling the actual retaining and releasing. But now down here, when we pull it back out, the moment we remove it from the inventory, that is going to cause a release on it. But we want to make sure that we flag this guy as auto-released when we return it. Anytime you return an object to somebody else, you should always return it as auto-released. So that somebody who's getting that object back from a method call has the responsibility to make the decision that they should actually retain it or not, if they want to claim stake to it. And apologies, I got to stop watching you guys talking over in BuzzNet. It's throwing me off. So anyways, this is a very, as you guys are going back and forth, we'll come back to that issue in a few minutes. Let's focus on this though. This is critically important what I'm saying. I don't want you guys to miss out on this. So that is why what I'm doing here is I am actually going to tell this guy that we're going to cause the retain count to bump up by 1. So now we're holding a reference to it. And now what I want to do is say that we've actually removed something out from the store. So we're in a whole new method right here. So let's just go ahead and do an NS string real quick. And this NS string is going to be, we'll just do text, and we'll say equals a NS string with format, and then we will just do the same thing we've been doing. And that is stores our designator as for the person sending this, and then we'll say a percent, and whatever it is, has been removed from the store. And then let's go ahead and do a new line and call our beverage that we're now holding a reference to his name. Okay. And then let's go ahead and log this out real quick. And now here's the final part of the puzzle. I need to remove it. So what I'm going to do is say stock, remove last object, and then I'm going to return, but not inside of that. And I'm going to return the beverage auto-released. Okay. So let's go ahead and I can put that down here just to follow the little comments that we put in there. Right there. Are removed, not removed. Where did I type remove? Oh, yeah. Trying to watch BuzzNet. My son has some emergency that he needs me to answer for him that just came in right beside me. And this all at the same time is just loads of fun. Okay, so again, a quick recap. We want to check to see if the store is open. Then we want to come in here and we want to make sure that we actually have stock. And then if we have stock and sell, if we have stock to sell, then what we want to do is grab out our beverage. We want to give some sort of indication that we have removed a beverage, or well, we're about to anyways. Mm-hmm. And then what we're going to do is tell the stock to remove the last object. Remember, this is what's important though. This guy is going to cause a release to be fired off on him. That is why if you just return the beverage back, and if you don't do this retain right here and just return the beverage back, you're going to end up getting a crash because you're going to have it getting over-released when you turn around and try working with it. So what we'll do is we'll retain it here. So we've bumped the retain count up by 1. I'm no longer interested in its retain count at all. I'm just saying that, look, for this method, I'm going to retain it. I'm going to claim responsibility for it for a second. And then when I give it up, when I give it out, I'm going to say, all right, at your convenience, let's go ahead and make sure this guy gets released. And that will cause him to be released. Okay? So by creating an object, by allocating it and putting it into an NSMutableArray, this guy gets his retain count bumped up. And then when removing him out, this guy will basically normally get him destroyed because it's been bumped down. But what we do is we ourselves go in there and say, let's go ahead and retain an auto release on return. And that is our purchase. And that also wraps up everything with the exception of simulate. So what I want to do is go ahead and hit Command S, Command B to make sure nothing explodes. And we're going to go on break. I'm going to pause video and make sure that everybody is indeed caught up. So let's go ahead and come over here and pause. Go.
Yes.
Welcome back, ladies and gentlemen. We're going to be continuing now. So with this, I do want to point out with the discussion that was going on while I was trying to type earlier, and I was trying to follow it while multitasking horridly, we discussed it during break. But I just want to point out, I know my if statement up here, my logic, it's very cheap for the example that is being given. I'm working with a 24-hour clock, and I'm going to be opening the store early, like at 8 a.m., and I'm going to be closing it late, like at 2 a.m. So the logic is extremely funky for that, and rewriting this so that it makes a lot more sense would be actually, just having a method that says is open or a property that you can simply read on and let it do the work for you to determine if it's open or closed would be a smart thing. But of course, tonight with simple if stuff like this, I wasn't going to bog myself down with extra code for making it look a little bit more, I don't know,
sexy?
Production friendly. So again, we're going to be going with the type, Slacker. Yes, maybe so. But hey, I was trying to give you guys a big class now. Come on.
Guys.
Slacker, how about cut me some slack?
That's right.
There you go. And besides, at this point, you guys should know how to go about putting logic in there to make it very nice. So that's right, Rowdy. I can't teach all night, and Rowdy's waiting for me to get to the good stuff. So what we want to do now, oh, geez. So what we want to do now is go ahead and move to the fridge. With the store, once again, we've got everything in place except for simulate, and I promise you guys all of the simulates are going to be very quick and easy to get in place. But let's, again, focus on the core functionality of the application. So moving over to fridge, let's jump into the header file at first. The important thing that the fridge is going to be keeping track of is going to be the beverages that are inside the fridge. So let's go ahead and set this guy up with an NSMutableArray just like we did before. And we'll call it Beverages. And then there are a couple of things that I would like to provide, just like we did over in the what do you call it? Store. Yeah, that's it. I want us to be able to list what is in the fridge. And Jonathan just asked over in BuzzNet, another NSMutableArray. Yes, think about it. The store is going to be holding its own collection of objects, and your refrigerator is holding its own collection of objects. So an NSMutableArray, and then we're going to go ahead and prototype out a few methods that we're going to need, starting with a list beverages, because we've got to see what's in there. And you guys watch for my typing and all. Next one is going to be add beverage. And of course, add beverage needs to take in some object that has implemented the iBeverage. Very good. Protocol. And we'll just call it
Beverage.
It's funny looking at us like Beverage looks so funny now.
I know it does.
And then finally, I need to return some object that returns, or excuse me, that implements iBeverage. And then this guy will be the remove beverage. Yes. Okay, so now that we got these guys in place, let's go ahead and do like we were doing earlier and just simply Command-C to copy. So everybody got that? Just a quick 2-second pause. So let me go ahead and pause real quick, make sure everybody's with me. Zoom. Okay. All right, cool. Everybody is with me now. So let's go ahead and jump over into our fridge and let's do some implementation. So let's go ahead and paste these guys in place. And let's just, once again, real quick stuff. Everybody should be really fast at this. As a matter of fact, you guys should be faster than me because I'm having to type in the most horrid keyboard combination in the world.
He's got like 27 keyboards.
I kid you not, it's ridiculously horrible. It's so much easier doing VTMs and all on one computer as opposed to a lot of computers. Also, I'm going to jump back over into Fridge and I'm going to import my log because I know I want the fridge to be talking to me. So let's go ahead and have it there.
Wouldn't that be neat if your fridge actually did talk?
Heck yeah. So now let's go ahead and start taking a look at getting an implementation in place. So let's start out with a simple init. So if I was to come in here and say initialize a fridge, what would I want to have happen? Well, I got an array that absolutely must be set up for me. So I would just come in here and be like all, you know, we're going to do an if, and I'm going to say if self equals super init, because that's all cool and stuff, and if it all works, then I'm going to come in here and do all this and
Beverages.
Be like return self like that, and then I can just come up in here and say, look, beverages is going to be equal to, and I want to create another empty NSMutableArray, so I'm just going to do NSMutableArray array. And I'm not going to worry about all the other nice stuff that you can do because this is all I need to do. Now what we're going to do is jump down here to our list beverages and let's get a list of these bad boys. So I'm going to jump in here first with a if. We need to make sure that we actually have something in there. So we're going to say if the beverages count is
greater than 0.
Greater than 0. Don't yawning, Lino. It's killing me.
I know. It
oh
just,
my goodness.
It sneaked it up on me.
So, and here's why. I want to do a fast enumeration through this. So we're going to do a for. So fast enumeration, I'm going to do an ID beverage. And we'll call it bev in beverages. And then what we want to do is ns string. Ooh, got that in my, I don't care. txt equals, I'm not going to sweat it, ns string, string with format, and then we're going to, again, designate who this is coming from, and I'm going to say it's coming from the fridge. And then we're going to say beverage, percent at, and then let's go ahead and oh, let's give it some extra information. We got the temperature as well. So how about we just say current temp, and let's give this a %LD and Fahrenheit, and then a new line. And then let me adjust my mic. There we go. And then let's go ahead and send over the beverage's name. And let's send over our beverage's temperature. And let's terminate that guy. And then let's go ahead and log that out. All right, good deal. So now we have the ability to list through, pull out, and spit out to the console all of our beverages. So now we need to add some beverages in. You okay, Nina?
Yeah.
Adding beverages is actually pretty straightforward, fortunately. Let's just jump in here and say, what we're going to do is say beverages, add object, and we're obviously sending a beverage in. And so we'll just take that beverage and him and add him in. And then poor Nina's about to die on me. I'm going to come up here, and just because of all of the typing and time, we'll copy this and
Smart man.
paste it down here. So we'll do an NS string with format, fridge, and we want to say, what, beverage added.
There you go.
And % that, current temp, and then we're using beverage here, so paste, logged out.
All right.
So now we've added our beverage into the fridge. So now that brings us down to remove. And remove's not that bad. We're basically dealing with the exact same thing that we saw over in the store. So we want to make sure that starting out, our beverages count, if it is equal to 0, then we want to vomit.
I'm going to cry.
Then we're going to come in here and we're going to do a log. And then the log's going to simply be text. And then the text is going to be, oh my God, we have nothing. And so we'll just say again, it's going to be a message from the fridge.
The fridge is empty, fool.
Exactly. 2 dashes, and then we're going to say, kiss my butt because the fridge is empty. Moron. It's Nelson's fridge, so we can say things like moron to him. We could, moron, go buy some beer. There, now I feel better. All right, so we're just going to simply say that. And again, this is a situation where we need to make sure that we return back nil because we didn't remove anything from our fridge. So the next thing we want to do is, so we passed the moron test, is we want to go ahead and grab a reference to a beverage. So let's go ahead and do that. Again, I'm going to hold an object of some type that is adopting the iBeverage sexiness. And we shall call this bev. And we're going to say that bev is going to be equal to beverages. And what we want to do is point it to the last object. Thank you, sir. Like such. And now, as I need to scroll a little bit, there we go. So now we're pointing at the last object. And I'm just getting lazy. I'm going to retain it because we're getting ready to do one of those magical release things. And so I just want to make sure that we stake a momentary claim that we can auto-release when we return it. Okay, so now that we've taken this guy and pulled him out, let's go ahead and let people know that, hey, we took some crap out of the fridge. So, sorry.
Stuff and things.
But that's exactly what I'm going to say here. We're going to be like, we took some crap out of the fridge.
That's
so,
awesome.
Yeah, when using this setup right here, no, we do not. You need to use a pointer because it's, yeah, we don't need to use a pointer. It's not a pointer. So now we're coming string in a fridge, and we're just going to come and say removed and just what it was that we removed. So I don't want to. I'll do this. Beverage removed from how about just beverage removed? And then let's say what its name is, and I could care less about the temperature. And say, nah, I was going to say you have less crap, but forget it. So we want to do, and it's not beverage, it's bev here. And name, and we don't want the temperature. I could care less about that, so let's just close that off. Okay, so finally, we need to actually remove this guy. So we're just going to come over here to our Beverages NSMutable array and tell it to remove the last object. And then we are going to return, and then we're going to return our bev, but it is going to be auto-released. Again, at the end of the day, getting rid of where we retained it, releasing it, because it's already going to be released from removing it back out of the array. So I'm going to go ahead and hit Command S and Command B to see if my typing was horrible. Booyah! And it was not.
Woo woo.
So what I'm going to do is pause video real quick. Okay, guys, we're back from that. So we're going to move on from Fridge. So at this point, we have got everything implemented in Fridge with the exception of Simulate. Once again, we're going to handle each person's Simulate as soon as we get back. Or as soon as we get the core functionality in place, which we're very close now. But now we're getting ready to move on to person. And with dealing with person, this is where the whole blood alcohol content concept comes into place. And I just had to have one way, at least one quick example of getting an enumeration into what we were doing in a project. And so this is the place for us to do it. So an enumeration is going to allow us to define a new type that will let us simply create variables of that type and assign very user-friendly reading values to it as opposed to like the number 1 or the number 2, etc. So let's just jump right into it and do it. So I'm going to create a header file that is going to be all by him lonesome. So I'm just going to do, I'm going to pick a keyboard to work on and do Command N. And again, guys, follow along. So I'm going to come over here to C or C++, and I'm just going to do a regular header file. And next. And here's what we're going to call this. So now we're deviating from the path. We're going to call this guy the Backstage.
Haha, good one.
So Backstage is going to basically give us our stage of drunkenness that Nelson is experiencing, or whatever our person is experiencing. So again, BAC stage, just a header file. We're going to hit create, and I'm not worried about the if not defined, and end if directive compiler directives. Bleh, you can't speak today, because again we're going to be using import for this. So I'm just going to kill this out, and here's what we're going to do. We're going to do a type def, and with the type def we're going to be doing an enumeration. And it is going to be called Backstage, or BAC stage, like such, with a terminator. And then inside here, this is what we're going to put. Normal, meaning person has not consumed any alcohol yet. Slight buzz, they've been consuming alcohol. Buzz, yeah, baby. They've been drinking a lot of alcohol. Emotional.
Yes, when you that emotion.
I need emotional because I have a video of Nelson very drunk and emotional. So that has to go in there. They be drinking a lot of Jason Busby. Yeah, emotional. Which means from there we just go to pure drunk. From drunk, they go to
unconscious.
Unconscious. And if we manage to pass unconscious, death. And you may be thinking to yourself, well, how could we possibly pass unconsciousness and go to death. Because we're unconscious, how can we drink? Remember, this is cool. This is where everything is all starting to tie together. Remember, with any beverage, we have the ability, or we can set the blood alcohol content modifier. So what if we specify a blood content of, that it would affect your blood content by, we're dealing with normally fractional values, right? So what if we say it's going to affect it by 3?
Yeah.
You just fell over dead.
One drink of poo.
I mean, you're like, ooh, this is and face plant. So and I'm serious. So what we're going to do is we're going to make sure that we account for something so horrible that you consumed it and died. Okay. So, hey, come on. We got to have some fun, right? So
moonshine gone wrong or something.
This is all that we need to type. And to be able to use this new Backstage type, all we need to do is make sure that we simply import this Backstage header file. So let's go ahead and save this guy. So now that we have him in place, I want to create a utility. We're going to create a class called a back calendar. And what I want to do is I want to offload calculating our blood content level to this calculator. I don't want that being part of the person. The person's already going to be big enough because we're going to have a lot of fun with Nelson's drinking. So, so what we'll do is a command. Oh, is everybody good? If anybody needs any extra time, just shout out in BuzzNet.
Oh, Jonathan.
I'm just ignoring that. And so, okay, everybody's okay. So let's go ahead and jump over to Command N, and we're going to come back up to Coco and do an Objective-C class. And we're going to go ahead and add the class in. And this class is going to be called a back calculator. So this is our blood alcohol content calculator. So let's go ahead and just hit next and enter to create it. And what we need to do in this guy is we need to make sure that the header file is aware of our Backstage. And then we need to set up one class level method. So we need one class method, which is going to allow us to simply get the stage based off of a blood alcohol content that gets passed in. And again, we're going to be doing this as a class level. So let me just do a little spacing here. There we go. So this is going to be a Backstage is what is going to be returned. And we're going to call this get state for blood alcohol content. But what we need to do is make sure we take in a float. And we'll call it back. And I'm going to go ahead and take a look at what I've typed wrong because I am typing where? Am I in the implementation file? I am just losing my mind. So I'm going to copy this and go over here to my header file. I'm just kidding, guys. See if anybody's with me. You guys are all asleep. What's wrong with you? And I'm going to go in here and get the implementation set up. And yeah, stuff like that. And I'm also going to come back over here and I'm going to grab this guy and move him over here to my header. Man, you guys failed that test horribly. What's wrong with you? And then finally over here in the header file, as you guys know, we're prototyping this. And so we'll simply make it into a prototype.
All better.
So jumping back over into calculator. Now let's do an implementation. I don't know why I converted that the other way. All right, so now we're going to do an implementation. Very simple stuff. But this allows me to, well, no, we'll do it in another place. Hang on. Now I'm going to say if, and we're just going to do a series of if. So if blood alcohol content that is sent in is less than 0.029, yeah, some of this was looked up, then we're just going to simply, return normal. check it out. I can just type in, since it knows that the return type is of Backstage, I can just simply type in normal now. How cool is that? So we'll type in normal. Now I don't need to do else if constructs because we've returned, so I'll just continue with a bunch of ifs. So let's go ahead and copy those guys. So we'll do 1, 2, 3, 4, 5 more. 2, 3, 4, 5 more. And so the next one is going to be 0.59. And if you're 0.59, you're going to be feeling a slight buzz. Next one up is going to be 0.9. And if you're 0.9, let me tell you what, you're feeling the buzz. From there, what we're going to do is move us on up to 0.19.
You get emotional.
One of Nelson's favorite places. And we're going to become emotional. And then finally, we're going to go up to 0.29. So let's just take that 0 out.
And then you're drunk.
And you're going to be drunk. Now, if you happen to be at 0.39, you're unconscious. Yeah, baby. And if we make it past all that, you died. Easy enough. All right.
In Nelson's case, you can be unconscious and still drive a boat, apparently.
Let's go ahead and pause for just a second for a station identification break.
Okay.
All right, ladies and gentlemen, we are now back. All students are caught up and jamming along nicely. So it is now time for us to move over to person. Inside of person, we'll have all of these things kind of all tied together. And then after that, we just jump over to main and bring it to life. We're really getting close. Now, here's the sad part. Person's huge. I mean, it's kind of big, right? I mean, so let's find out. But it's a bunch of switches because again, I wanted to get switches in before the class was over as well. So why not? So let's go ahead and bring in a few more things. So here we are. For those of you following, all of you, let us go ahead and switch over to the header file for person and make sure that we are importing what all do we need to bring in here? We need to bring in the Backstage header. We're going to need to bring in the back calculator header. Let's see, we need to bring in the fridge. Let's see, we need to know about the store.
And the log?
Yep, because we're definitely going to be saying some stuff in this one. We're going to be bringing in the log. And
math?
And we're going to be bringing in math. And this is going to be system, so math. All right, and you'll see why here in just a few minutes. So we'll bring all these cool things in. And now let's go ahead here inside the interface. Let's go ahead and create a few different data members that we're going to need. So the first one is going to be an NS string for our name. And then I'm going to pretend that didn't happen. And the next thing that we're going to do is going to be a bool.
Is alive.
And we want to know if, the person is alive. And then we're going to do a float for the blood alcohol content level. Sweet. Now, as we're all experts on it, let's go ahead and create some properties. So let's go ahead and have the first property, which is going to be an NS string, and I want to retain it. So coming in here, let's say we want to retain. And it's going to be non-atomic. And it's going to be an NS string. Name. And then let's also give, let's give a property for is alive. But think about this. Is alive needs to be read only because I don't want an external class to be able to kill the person. I'm serious.
Smart thinking.
The first time I wrote this program,
Oh God, I remember you telling me.
Yeah, I
this.
laughed so hard, guys. Nina actually came in here from the other room, and she was like, "What's so funny?" And oh God, it was hysterical. I didn't actually run it to see what execution looked like, and so I just kept on, and then put everything together in main and ran it, and the menu came up. I was like, "Oh, sweet, good. Looks like everything's in good shape." There was no errors, and I went purchase, and as soon as Nelson purchased a beer, he fell over dead. I'm like, what the hell? That made no sense whatsoever.
Bought a beer and died.
Yeah, there was a couple little bugs in there, but no matter what Nelson did, he died. So we want to make sure that nobody is allowed to tinker with is alive. Again, encapsulation.
Read only.
Kind of driving that concept home. So let's go ahead and come in here and say that this is going to be a read only. Good guy. And again, just out of habit, we'll do non-atomic. And again, it's going to be a bool in this case, and we're setting up for is alive. Cool. All right, let's go ahead and give ourselves a few different prototypes for some messages. No beer for people under 21. Pencil, you're absolutely right, but there's homework. Like a purchaser, age, log stuff. I'm writing a few notes down because Nelson, who is aware of what homework is no longer with us tonight. So that puts me in an even more awkward situation. Not a problem. All right, so first thing I want to do here, I want to make sure that we have the ability to instantiate a person with a name. So let's go ahead and give our typical init with name. And this is going to be an NS string pointer. And we'll just say that it is going to be a new name. And let's go ahead and do a bool. And this guy is going to be consume. And consume is going to take in, and hang on, it's okay, Nina, don't worry about it. She went in there and tried to get Nelson up. So consume is going to need to take in a beverage to actually drink. So again, some object adopting the iBeverage, taking in a beverage. And then finally, the important one, and that is going to be Backstage. And with Backstage, we want to be able to get Backstage. And then, wait, no. Nelson would swear that here is the perfect one that he must have. And that is he wants the ability to actually purchase alcohol. So for purchasing, here's how I want to handle this. I want to be able to specify what store. So I'm going to actually require a store to be passed in when making a purchase and where you want to store the purchased alcohol at. So, and store here. So just know that I mean store like in storage. So store it here, and this is just going to take a fridge. Not a frigid, but a fridge.
That was cute.
All right, so let's go ahead and give you guys just a second to get this in place. I'll pause. Okay, so all of the students are in awesome shape. Hopefully those of you at home are following along and you're in good shape as well. So now that we have got our person header all done, it's time for us to jump over and get things rocking over inside of our implementation. Now, once again, I'm going to simply do a Command-C to copy.
Smart.
And then I'll jump over here to our implementation file and jump up and paste. Lots of problems. Looks like we're having a Friday class this week. Whatever, MMO. I'm not even... okay, maybe I'm a little tired. Ashley's been so quiet for long, I don't even know if she's still here.
Ashley!
So, it's all... And MMO's... Oh, wait. Dang it, Matthew got us. It is already Friday. We are having one. All right, so
Yay!
now what we're going to do is come in here and make sure that we
Yes. Huh? What?
we go ahead and synthesize. And so let's go ahead and copy these guys and paste. And let me also adjust my notes here so I don't leave anything out, because this one I need notes because there's a lot of stuff. All right, so we've synthesized that. Next thing I want to do is go ahead and rough in or skeleton in our prototype methods real quick so that there are at least base implementations.
Grandma's what club?
I don't know. Sweet. So now that we have these guys all in place, the next thing I want to do is go ahead and let's start first with what happens if somebody just does an init on a person without doing an init with name. So we'll handle that scenario. So I'm going to do an ID, and then we'll just say init, except this init is going to be a call to our selfs, init with name, and say hello to John Doe. And yeah. And now for our init with name, let's go ahead and do the standard if self equals call supers init. And in here, we're going to say name is going to be equal to new name. Again, not having to worry about memory management because, again, we said that we need to retain. Next thing is going to be our is alive. I want to make sure that we start each person off with a wonderful life, so we'll set them alive. And let's go ahead and start each person off with a blood alcohol content level of 0.0. And again, it's a float. So just initializing some stuff, and we're going to return our self. Sweet. So again, here we are. Yeah, we could play, well, we could start this off with them dead, but then that does no good because they can't do anything with the way the structure works for the application. But it would be interesting.
Ashley, that was cute.
So, oh boy, consume. Yeah, consume's a little involved. But consume's fun. There's going to be a lot of copy and paste. So, everybody in good shape here? Let me go ahead and reset. And go ahead and click the wonderful button for me as soon as you guys are ready. I'm trying to baby feed you because as soon as we get into consume, it's going to become pretty lengthy. Let's go ahead and pause. All right. All students are go. So, it's time to begin working with consume. Consume is not bad. It's going to be big only because we're just going to be using switches to check different scenarios and having a little bit of fun with it. And instead of doing we're just going to go ahead and set ourselves up for NS string right here at the very beginning. Because we're going to be using this guy a lot because it's all about messages now. So first thing we want to do. So we have called upon our person, told them to consume something, and we have sent them a beverage. So they should be able to drink. So what I need to do is verify that they are first alive. So if they are not alive, notice I used not alive, then we're going to simply return false. And now remember, consume is going to return a bool. True, we consumed it. False, we did not consume it. Next thing I need to do is, next thing I need to do is to check the temperature. Because we know Nelson refuses to drink anything with a temperature above 48 degrees.
So civilized.
That's right. So we're going to do an if statement, and we're simply going to say that if the beverage dot temperature, did I not synthesize that guy?
I don't.
Hang on one second. His name, that.
Oh, I can't remember.
Hang on. Person is going to be, wait, no, not person. Temperature is going to be over here on our beverage, which is going to be back over here on beer. And
There's
beer,
temperature. Oh,
temperature. So we synthesized it there. And yeah, so it's part of the thing. And, oh, let's go ahead and, my bad.
Oh, did it not do the thing? And
I'm going to
import it.
I'm going to
into
import
the person.
beer. That's got to be what's giving us trouble here. It's got to be, what am I doing? It's got to be my ordering of what that's what's going on. It's just simply my ordering with import. So now, yeah, now I've got my, my if temperature is above 48 degrees. Then what we want to do is we're going to say text is equal to an NS string because Nelson needs to complain about this. And we need to do a string with format. And this is going to be coming from the person. So we're going to do this. Because remember, we have the person's name being stored. And then we can say, too warm. We'll just let him talk like a caveman. I'm not drinking that. Uh-oh, Nina pointed at something.
Missed O.
Did I miss an O or did I?
T-O-O.
Oh. Too warm. Drinking that. Man, we will simply do a backslash in there, and then we need to make sure that we send the name.
All right.
Okay. And anytime we do this, of course, we're now going to turn around and log out our text.
I wish that you could have some kind of way of spelling that thing he does, because that's what he would do.
Oh, yeah. That's true. Meh.
Meh.
And so here is another situation where we have not actually consumed the beer, so we're going to return false. All right, now, the big one. I'm going to create a variable here. And this is now completely up for, well, I'll discuss it more in a second. We're going to create a bool. And it's going to be do consume. Because we need to check a few things. And in most cases, Nelson is going to be able to drink. He'll be able to consume it. Most cases meaning, you know, as long as he's not dead, as long as he's not unconscious. So let's, you know, if he's normal, slightly buzzed, whatever, he's going to be able to consume it. So we'll set it to true because it's going to be that way in most cases. Now, what we're going to do is you can consume alcohol while you're unconscious. With assistance, maybe. And if not, yeah, okay, with assistance. Good. All right, so now what I want to do is do a switch. So a switch statement is, I had mentioned it back in the first week of this class, but said we weren't going to be looking at it in this class. I decided I wanted to put it in there so that you guys have at least seen it. The switch statement is simply going to allow me to take something that is going to have an evaluate to an integer expression and switch off of it based on what it is. So let's go ahead and say, in this case, our switch, so I just hit tab, and the expression is going to be, we're going to call upon ourself, and we're going to send a message to Backstage. Okay, so remember, Backstage is, did I not do Backstage? Oh, there's Backstage right in front of me. Backstage hasn't been implemented yet, so we'll get to that in a few minutes. But we're calling upon it to tell us what stage we're at based off of our alcohol content level. So with it now knowing that that's what we're dealing with, I can come down here to our case and watch this. I can just say if we're normal. How cool is that? So if we're normal, our text is going to be NS string, string with format, and again, we're going to, and after this one, I'll start copying, pasting a whole lot of stuff. So don't worry about fear of, oh, dear heavens. So, and again, I need to space this guy and object. And we're going to have, so if he's normal and we're going to consume a beer, it is time for beer.
Yay!
And we'll feed in our name. And then let's go ahead and log that out. And I did have the question over there, what is the benefits of using the switch? Once all of this gets put into place, I mean, you could have used the if, else if construct, but in this case, I find when, because it's kind of what you're doing, you're switching between which one of these guys is the case, as opposed to going through and say, if it's this, no, all right, well, else if it's this, oh, no, else. This is just easier to read, in my opinion, but you could surely use if, else if, else constructs. So we'll go ahead and say, let's log out this text, and yeah. Now here's the deal. When we say switch, we have our integer expression evaluated in here, and that is all our enums evaluate to. They start out at 0. Now we can come in here and I could say equals 5, and this would actually start normal at 5 and count up from there. But we can just leave it at normal and let it just come up with its own numbering. Let's go ahead and jump back over into person. So again, we've got normal, everything's set up there. So now let's just copy and paste. Oh, I do want to point this out. Default. If we have a bunch of cases and none of these cases apply, then what's going to end up happening is we're going to hit default. So default is our catch-all. So now it's time to copy and paste and make this guy grow quickly. So copy, paste. Now let's make this a little more interesting. In this case, this is going to be if he's buzzed, or, watch this, or if he is slight buzzed. And let me put a space in there. You can stack these guys.
Oh.
So this is very cool. Having these guys stack, then what will happen is this guy and this guy will both respond to this. And as MMO Dust added in over in BuzzNet, I will go ahead and throw this in. Break is not a requirement in this language, from those of you guys from the world of C and all. If we do not have break in there, what happens is, if normal is the case, we simply start falling through, executing everything until we hit a break to get out. So I personally like making sure that we always have breaks in there, and if we have something that, if we need to stack like this, so if he's slightly buzzed or if he's buzzed, then let's have him come in there and say something like, woo!
I was just thinking that. Woo,
that's Nelson.
beer.
He's like, woo! Whoop-oo-hoo. No, that's getting a little drunk there. All right, so that's him slightly buzzed. Now, what happens if he becomes emotional? So, and this may look like a lot of code, but remember, I'm just copy and pasting. So we're going to come in here and do emotional. And with emotional, let's say that, all right, so this is Nelson. And when Nelson gets emotional, he's like, I love you, man. I really, I do. That's Nelson. Okay, so this is Nelson getting all emotional. All right, so if we are, let's say, drunk and we're about to consume another beer, he's going to be one happy dude. No, not death. So in this case, he'll just scream, beer! Because I've seen him do that, except he's actually screaming it. So this is if he is drunk. Now, let's do one more. and that is going to be if he's unconscious. He's not going to be saying anything. What I want to do is, instead of him saying something, I want to denote an action. And we'll just say that we'll denote actions with putting in some asterisks. So I'll just come in here and say something like
face floor.
Yeah, face floor, on couch, gurgles, blah. Now we'll just leave it with gurgles. That's all we're getting from an unconscious Nelson.
Yes. Or snoring.
So, but with an unconscious Nelson, so check this out. This is our first scenario where do consume needs to be flipped to false. He didn't consume the drink. He's just gurgling away on the couch or wherever he's at. Okay? We're going to have to put him on the couch here in a minute. So, all of this is us getting up to the point of going to consume. So, the next thing I want to do, and of course we're going to break out, is I want to see if we actually did a consume. So at this point, let me go ahead and give it just a second for those that are following along, because I know how challenging it can be to listen and type at the same time. Try talking and typing at the same time, and reading. That's a fun one. So let me go ahead and pause. All right, we're now back and continuing on with this amazing feat. So moving forward, next thing we need to do, so now that we have gone through and checked to see if we are able to do a consume based off of the alcoholic state of the person consuming, well, the beverage, the next thing I want us to do is check to see that if we, if it's not consumed, if not do consume, then we want to return false, okay? So let's, here at the end of the switch, and I do want to point this out really quick that Seaby had asked about earlier. So with the switch right here, I just used the code snippet and tabbed it in, which automatically puts the opening curly brace at the end of the first line. So I can just move that down because, again, from C#, that's how I prefer it anyways. All right, so moving on down, next thing we want to do is... enter. If, so now we're going to be using that not do consume. So if not do consume, then what we want to do is return false. Okay, so the next thing is going to be, since we know that we can consume, let's go ahead and do it. We're going to take our beverage and we're going to call consume. Okay, then we are going to, in this particular case, since we've consumed our beverage, we can just go ahead and, oh, you're good. We can just go ahead and release it. And not worry about it. Just done. But now, what we want to do is take, hang on one second. I'm actually looking over at my notes, and I'm wondering why I did that. Is it because everything's looking crazy at this hour in the morning? Because I did a release from a beverage that's been sent in. That is... oh, I'll go with it at the moment. Okay, so, but I may be revisiting that. All right, so now, next thing I want to do is I'm going to take the blood alcohol content, and we're going to say plus equals. Here's why I'm curious about why I did why I sent a release message to it, because I'm going to continue working with it. Which is interesting that I did that. But anyways, let's go ahead and say plus equals beverage, and I'm going to do the back modifier. So let's make a call to that. And push that off. And so what I need to do is simply make sure that the blood alcohol content has been increased for the person who just consumed the alcohol. Next thing I want to do is simply say if, and we're going to check to see if drinking this right here caused him to actually, well, you'll see. So let's just call self, and then let's call backstage. Let's try that again. And then self backstage, if this is less than, so if he's less than buzzed, then what we're going to do is we're going to, and I'll just copy this stuff again. For time's sake. And paste. And we'll simply say that the message going out is going to be like throws bottle in the trash or something. Because he, at this point, is not going to miss. Yeah, we'll do it like that. Otherwise, so else if, and then once again, self backstage. So in this case, if it's less than unconscious, so now he's you know, getting pretty happy. We'll paste that in there, and we'll just say that the bottle simply falls to the ground. All right, good enough. So if he's unconscious, we're not even going to make it to any of that stuff anyways, because, well, yeah. So anyways, moving on down. So the next thing that we're wanting to do, it's funny because trying to scroll through my notes over here because I wasn't able to print stuff out. You work on the Mac for so long and I'm scrolling in one direction. Then I scroll over here and it's the opposite direction. And it's like completely screwing me up right now. Serious as a heart attack. Okay, so make sure all of that is good. And that brings us down to here. And now looking over here to Cby's question, why is it else if this time rather than how we did the consecutive ifs before? The consecutive ifs before, if you recall, in each of those ifs we did, we returned. So we didn't need to do an else if because the return ended our execution inside those methods. Gotcha. Good. Okay, so, and here, of course, we're not returning. All right, so we've got that in place. So let's see, what do we want to do next? We're going to, so now we've adjusted our back modifier. So our blood alcohol content has now been affected. Let's see how we respond to dealing with that. Now, I'm going to just come up here again and speeding up time. I'm going to grab this switch statement. So I just grabbed the first one. I'm going to come down here and I'm going to paste it. Again, speeding things up. So same exact thing. So we've got our backstage. So we're going to start out with normal. He just consumed a beer. What do we want to say? So let me just jump this down a little bit. So he's going to say something like that, because right here he's normal. So that was tasty. But it didn't do much. Okay. So now if he's got a slight buzz, actually we will break slight buzz and the other one up so that we can have just a little bit more interesting stuff going on. So I'll copy that. I'll paste it down here and take this one out here. This way we're responding to slight buzz and buzz. So with slight buzz, let's see, what kind of message do we want to give? Hey, everybody. I'm feeling awesome. Because that's exactly how he sounds. With a slight buzz. Yeah. All right, so now that he's talked about feeling awesome, what happened if he's actually has a buzz? Well, here's what I picture. Was that a pony?
I was going to say something about a pony.
It's got to have some pony in there.
You have to say something.
Dude.
Dude.
It was. There we go. So now, you know, Nelson's starting to feel it. And so it's time to start becoming emotional. And so let's see how he's going to handle being emotional. So now he's just elevated himself to an emotional state. He wants to tell everybody, I love ponies. So much. I just want to hug them all. All right. Yeah, that'll work. So now what happens when we go past emotional into being pure drunk? This one's an easy one for Nelson. Pony time. Actually, let's say it more like, no, that's actually good. Pony time. All just kind of one word all together. Because that's exactly what he would say. And if the consumption of alcohol just pushed him over to where he falls unconscious, the action is going to be passes out on the couch. All right, so now he's on the couch. So next time around, we can gurgle as we are laying on the couch. And now, what happens if drinking that elevated us to, let's go ahead and take this do consume out, because we did just consume it. So now what happens if we elevate ourselves to death? You're right, Mr. Seaby. Let's bring some death action in here. So obviously this is going to have to be some sort of action. So let's just say that Nelson kills, let's do this all caps, kills over dead. It's getting late. I'm not creative. And turns cold. And turns cold. There you go. I'm just taking feedback from Seaby, okay? So, all right. So now that we've got all of this going on, next thing we want to do is we were able to consume all this good stuff. We've, believe it or not, made it to the very end. So we are now going to simply say return true. Because all of those other scenarios where we were returning false, they all dealt with not being able to consume the beer. So if we don't consume the beer, we need to make sure the beer something gets done with the beer, which we'll see in just a few minutes. So, wow, that was the biggest one.
We did it.
Let's see. Let's save that. And let me do a Command B real quick. And we've got one error.
See my pony time.
We're there we go. Oh, yeah, Backstage. So we need to go ahead and implement Backstage. And it looks like I'm actually going to override isAlive as well. Now, if you guys recall, isAlive is a property. And so if we come all the way back over here to person header, you'll see that isAlive is a property. And again, I was just trying to get examples of everything in. We have the property is being synthesized for us, but what I want to do is come back over here and I'm going to override isAlive. I'm going to override the getter with my own, and the compiler is going to see this and override it. So again, just this demonstration purposes and showing you that we can actually do this. So it's not that it's overriding, it's just telling the compiler, don't synthesize a getter. So let's go ahead and do that real quick. So we're just going to come in here and say, we're going to be returning a bool, so our signature needs to match, and it is alive. Oh, really? And all I want to do is say, if is alive, then we're going to return true. And here's the reason I'm doing this, though. Because if he's not alive, whoever just like checked in on him needs to be spanked. Needs to be told that. So I'm just gonna again copy and paste, and it's gonna be an NS string pointer. And so NS string text, and we're gonna say NS string with format. And whatever we just checked is just going to be is dead. Unable to comply. So whoever the heck just, asked, that's what they're going to get out of it. So we'll simply write that out, and then what we want to do is return false. And what I just wanted to demonstrate here is now we've taken a getter and we've taken it an extra step and we've written some logic in there. So it's not just a matter of returning the true or false state of is alive, but we've also done some stuff. So that message will be very helpful for us back over on the console. Okay, so finally, let's go ahead and get Backstage in place real quick. So Backstage is super, super simple. We're simply going to say return, and then this is where we're going to make use of our back calculator. And we're going to call get state for back, and we're going to pass it whatever our current blood alcohol content is. Okay. So there. And I do believe, oh, that's everything but purchase. We need to be able to purchase. Ah, man, we're so close. But purchase is easy. So let's go ahead and just put that in real quick. So purchase is going to be a matter of first, let's go ahead and do an ID iBeverage. And we're going to call it a beverage. And we're going to say store purchase. And now what we're going to do is simply say that if the, back up one, if the, if beverage is equal to nil, oh, come on, work with me here. So if beverage is equal to nil, then we are having a hard time with our keyboard here as it gets later and later. Let's go ahead and do some copying pasting because we're going to need to, once again, send out some information. And so this person is going to say purchase failed. And then since it's Nelson, he's got to be sad. So we'll just be like, aw, and sad face. And this won't be an action. This will actually be him screaming this at us. There we go. So we'll log that out and we'll just return back. So otherwise, our purchase was successful. So with it being successful, we'll simply say fridge, and then add beverage, and then beverage. So the beverage that we just got, we simply add in. And space that out, and build. Hey, look at that. No warnings, no errors, no nothing. Yes. And we're going to pause for a second.
Mickey Mouse, any mouse.
All right, ladies, welcome back. Oh, and gentlemen. All right, so all students are caught up and ready to move forward. So at this point, we're ready to go to main. We're ready to write our program.
Yes!
We've spent hours setting up all these classes and relationships and all this good stuff. So let's go ahead and let's see. I'm looking through notes to see if I even have a main that I can, so I don't have to like just write it on the fly, even though part of this all is tonight. All right, well, that's good enough. Let's just jump over to main. Oh, wow, look, here we are back to like nothing. So in main, let's go ahead and bring a few things in. So right now we're bringing in Foundation. Let's go ahead and import our environment. You're so awesome, Nita. Let's import store. Let's import our person. Let's import
fridge.
Fridge. I thought you said French. So what?
We're not importing the French.
Let's import
log.
I can't hear that without thinking of Ren and Stimpy. Okay, so now what we want to do is, this is where stuff's going to get fun. We're going to come in here and we're going to make, that was not me yawning, I swear.
That wasn't. Nope.
We're going to create an NSMutableArray called Simulations. And we're going to, let's go ahead and actually create this guy as an empty array. All right, now, basically, we're going to add all of our simulatable stuff into simulations. So now let's have some fun and make some things. Let's start out with our environment. And let's call this guy env. And he's going to be equal to 1, 2, 3, environment, alloc. And we're going to do an initialize with time. And the time is going to be, let's say, 2 o'clock in the afternoon. And let's go ahead and auto-release this guy, because we're using alloc here. And that is one of in the rules for when you need to worry about retaining and releasing and all that good stuff is when you are using alloc. And so we'll go ahead and just set it up as auto-release and not worry about it. All right, so the next thing, let's go ahead and create a store. And our store, we'll do 3 of those. So let's do store, alloc. And then let's go ahead and initialize this guy. And we're going to initialize with an environment. So we can go ahead and hand in env to him. Now let's initialize an opening time of 8 o'clock in the morning and a closing time of 2 a.m. Again, using a 24-hour clock. And let's go ahead and auto-release. And let us go ahead and terminate.
Terminate.
And let's hide that guy so that I can see more. All right, and what are we? Store, S-T-O. Oh, there it is.
There's the R.
I was looking for the typo. I knew there had to be a typo. It's the only way that made sense. All right, so we've got a store now. Let's go ahead and let's make a person. This is going to be our trusty sleeping during a class while one of the instructors, Nelson. Yeah, that guy. So let's go ahead and bring him to, oh, you were asleep earlier. There is no denying that because Nina beat on your door and beat on your door and beat on your door. Let's go ahead and alloc this person. And we're going to init him with a name. And the name will be just a constant string literal for Nelson. And then let's go ahead and auto-release him. So now we have a person. Let's get a fridge in here. It's nice just bringing all this stuff to life now.
I know.
So with our fridge, same party. So fridge.
Alloc. We're
going to allocate. And then let's go ahead and do a simple init. And let's auto-release them. All right. Now what I want to do is add all of these guys into simulations. So simulations, add object, and we're going to add in our environment.
Oh, no.
No.
I
did spell it wrong.
little thingy.
And our environment.
There you go.
And then just since I can't talk, type straight, or talk straight, let's just Command C. And environment, we got store, Nelson, and fridge. These guys all need to be simulated. So let's go in here and put in our store.
See, that's work smarter, not harder.
That's right. Let's put in Nelson. And then finally, let's put in our fridge. Sweet. So now that we've added those guys in, we're going to be doing a game loop, more or less. Instead of just saying while true, I'm going to use a switch in here, so we'll need a way of exiting out of our loop. So I'm just going to do a bool called doLoop, and I'm going to initialize it to true. We're going to need to get some input here. So we're going to do a char and call it input. And we're also going to hold a reference to, we're just going to set this up outside. I'm trying to remember why I actually did this. Oh, because of the, it's going to be the one thing we're going to be passing around through this because of the switch. So let's go ahead and set up an ID, Beverage, and we'll call it Beverage. And then let's jump in and do our while loop. So while we are doing the loop,
Do loop. I love that.
then let's have a good time by starting out with log text. And our text is going to start out, let's just bump us down with a new line and say 1 is going to be purchase. 2 is going to be store, inventory. 3 is going to be fridge inventory. 4 is going to be consume beverage. And 5 is going to be quit. And then we'll go ahead and do a new line after all this good stuff. And let's terminate that.
Yay.
All right, so now we're ready to, and we're not going to spend a lot of time on this. Here's this one you're just going to have to trust me on. I'm going to make this one quick. I need to do scanf, and for those of you that have worked with scanf on a more serious basis in the past, you know how much fun this is going to get into. I'm going to grab a character, and then what I'm going to do is I'm going to store it into the address of input. Now here's the interesting thing. If you, I'm sorry, I looked over at BuzzNet and saw what MMO
Don't
said.
run it right now. It's evil.
So yeah, it is. So if you, when you type in a number and you hit enter, what's going to happen is that character that you type in is going to be put into the buffer, our single character, and that enter, that character return is going to be, or new line is going to also be in the buffer. Not a problem on our first time through. But our second time through, the buffer is still going to contain that. It needs to be dealt with. We need to eat the buffer. And an old simple way of eating the buffer is simply saying that while input is not equal to a new line, or we can use getChar, which is another function that's available to us in the standard C library in standard IO, that allows us to also eat a character, so a new line. So let's go ahead and watch how I do this. I'm just going to do while input is not equal to a new line, and yeah, this is me like in La La Land. There we go, character, new line. And we're going to do getChar. And with getChar, as long as that is not equal, and that will eat that new line for us, end. I don't have to actually, and this is really cool here, I don't have to, what's the word I'm looking for? I don't remember what I was looking for, so I'll just continue. I don't have to worry about. We're eating our new new line character. Yes. Okay. So now that we've got that taken care of, all we need to do is just switch based off of our input. So I'll go ahead and do another switch, and the expression is going to be based off of our input. And then let's go ahead and take that down so it looks a little nicer. And then for our constants, that's the wrong mouse. I was just trying to use the PC. Not good. So we're going to say that if it's a 1, then we can come in here and say if Nelson dot is alive, because now I can take use or make use of the getter that we wrote ourselves over on the person class. And if he's not alive, this is going to, let us know. So, so if Nelson is alive, then let's go ahead and say, well, if he is alive, let us simply do a Nelson because we did purchase, let's go ahead and purchase. And we have to hand it a store. Well, we have a store for Nelson to go to. So see, this is where it all starts to kind of lay out and read as close to English as I can get it here. So Nelson, purchase from this particular store and store it in your fridge. As easy as that.
No.
And that's it. And break out. So now, if it happens to be the person typing in a 2, then all we're going to do is simply call upon the store and say, list your inventory. And terminate that. And we'll clean this guy up. If they happen to type in a 3, we want to see what is inside our fridge. So if it is a 3, then we're going to call upon our fridge. And what are we going to do with the fridge? We want to see what is inside the fridge. So we will list out our beverages that we're currently storing in the fridge. And break out. And let me go ahead and fix this fall through problem that I'm creating myself.
There's 3 of you.
There we go. Yeah, there are.
Well, there's like at least 2 of you to run the clock.
So, well, no, it's just me, man. Nelson had gone to sleep on me. First person ever to do that. All right, so 4. So if they hit a 4, and I'm going to go ahead and throw my break in there. What we're going to do is consume a beverage, but this is how this needs to work. And this is why I set that beverage up for us to be able to utilize outside the switch, because I cannot declare it inside here. So we're going to say that beverage is going to be equal to, and we're going to talk to the fridge, and we're going to pull a beverage out of the fridge. So fridge.remove beverage.
Thank you. Rick.
And now if the fridge actually gave us, so if beverage is not equal to nil, so we actually got something back from it, then what we're going to do is we're going to say if, because now we need to have Nelson try to consume it. So if, let's do not, and we'll say Nelson, and we'll make a message call to him saying consume, and it wants to know what beverage do we want to consume. Well, the one we just pulled out, so consume this beverage. So if he did not consume it, because remember I put the not operator there, so if he didn't consume it, what I want to do is say fridge. I want to put it back in the fridge. So we're just going to say add beverage back into the fridge. And break out. Otherwise, he did consume it. So now if we type in a 5, let's go ahead and throw our break in real quick, or I'll end up forgetting it. Okay, so here, what we're going to do is tell it to say thank you for playing and well, exit out. So we'll go ahead and do a log text. Thank you for playing. And a new line. And to exit out, all we need to do is simply say do loop equals false. And that's going to have us stop doing the loop. And then we're going to break out. Now I'm going to do one more scenario in here. And this is going to be the simulation of time is just if you hit enter. So what I'm going to do is I'm going to do a case, and I'm actually going to give the ASCII character here, which is going to be 10 for hitting a new line or for hitting the enter key. And with 10, let's go ahead and once again hit break. I'm going to come in here and say log, and we will log out something like, this is from the system, so we need to follow our convention with system, -- and then simulate time, which we will set all that stuff up in just a minute. And then, in fact, I can go ahead and code it in so it's done, because all the objects that have been added into our simulations NSMutableArray are all simulatable objects. Okay, our environment simulatable, our store, Nelson, the fridge. So what I want to do is come down here and just do a fast enumeration with for. So fast enumeration with a for in, and we'll just simply say that ID. So we're going to be pulling out an object of type iSimulatable this time around instead of Beverages. And then we'll just call it sim. And in what collection? Simulations. And what are we going to do when we pull this guy out? We're simply going to say take this particular simulatable object and call simulate. They have all been implemented as far as a skeletal structure, but they don't do anything at the moment. But it's at least in place. The code's at least in place. And I'll go ahead and fix this. And then that is what we are going to get if we just hit enter. Let me hit Command S and Command B. And let me just hit run and see what all blows up. I almost want to like pause recording so I don't get embarrassed too bad, but what the heck. Oh my goodness, we actually have a menu.
Yay!
That means that we managed to actually instantiate all of our objects. That's a good thing. So first thing I want to do, I see the first thing I want to fix. I want to give an indication that we're looking for some sort of, when you put your case 10, did you do it as a character? Or did you just put the numeric integer value 10, Mr. Matthew? Let me jump back up real quick. And let me put a, I was going to put a colon right there. And run this guy again. There we go, much better. So purchase, store inventory, fridge inventory, consume beverage, and quit. Good. So first thing I want to do, what's in the store? Holy crap, the store actually has stuff in it.
Yay!
Unbelievable.
We have 10 beers.
It's funny that I'm actually kind of in shock right now.
You're like, oh, it worked! Holy
So, oops,
crap!
hang on, wrong one. So, all right, so right now, our store has got 10 different beers in it. So let's go ahead and let's push our luck. Let's look at what's in our fridge. Uh-oh, we've hit our first bug. So I've asked for fridge inventory, and I've got no input whatsoever. So let's troubleshoot it real quick. And for those of you that are running into errors, I will be more than happy to help you get them sorted in 1 second. Let's make sure mine runs first. So let's go ahead and stop this. So first thing I would do would be taking a look at fridge list beverages in number 3. So that's good. So let's jump over here to fridge and list beverages. If our list count is greater than 0, then we're going to pull out a beverage and do all of that, or I need to actually say something like there's nothing in the fridge. And did I not in my original notes have anything like,
I don't remember.
Like what's in there? Yes. All right. So for anyone that's following me, I did, even though you guys might have programs that are exploding and there's blood and gore all over the ground, if you could like head back over to fridge for just 1 moment. I do want some sort of indication. No explosions and fixed. Excellent.
Yay.
I do want some sort of export over here letting me know that it's actually, empty. So I'm going to do a log text, and we'll just simply say that this is a message coming from the fridge. And the fridge is empty. Fool.
I was just thinking that.
Were you really?
Oh my gosh, swear. That's awesome.
So let me save that. So let's go ahead and command run. All right, so once again, checking our store. Wait a minute, what did I hit? Oh my goodness, I jumped the gun. I actually did a purchase. Holy crap, the purchase worked.
Yay!
So I hit 1, and you can see I get a message from the store saying a beer has been removed from the store. We get a message from the fridge saying that a beverage has been added, and we see what it was. It was a beer. And we see that its current temperature is 85 degrees. All of that is right.
That's awesome.
So now if I turn around and I ask the store for its inventory, if you guys recall, I had a count of 10, right?
Yes.
So let's take a look at what is in the store's inventory. 9.
Yay!
So we have 1 less beer. So now let me go ahead and take a look at my fridge inventory. So we're going to hit 3. Up. The fridge inventory contains a beer with a current temperature of 85.
Woo-woo.
So let's go ahead and purchase another one. So I'm going to hit 1 again. And so again, we get a proper message from the store saying a beer's been removed and a beer's been added to the fridge. And so let me go ahead and do a store inventory. We're down to 8.
Yay! It's
And
working!
let's take a look at what's in our fridge. So again, we'll just say fridge inventory. We've got 2.
Woo-woo.
So we've got 8. So purchase, that's 7, 6, 5, 4, 3, 2, 1. So let me go ahead and check what's in the store. So store inventory has a count of 1. There's 1 beer left.
Only 1 beer.
How many do we have over in the fridge? How many should we have, Nina?
We should have 9.
We should have 9. She's keeping track of those beers. So let's take a look at what's in the fridge inventory. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah.
No, I'm just kidding.
Oh, God! What?
We have 9. Good. So let's buy 1 more. All right. So now let's see what we have in our store. Store inventory.
You ain't got jack.
Total count is 0. Let us see. Well, we know our fridge is going to have 10 in it. So
See what happens if you try to buy.
if I try to buy now, boom, the store says we have nothing to sell. Go away. And Nelson goes, purchase failed.
Aww.
Sweet. So now our person is no longer able to make a purchase because the store doesn't have anything to sell.
Now we get to start drinking.
Ooh, but we have a problem.
Oh, no.
We don't have a problem.
We don't?
We have one more thing that we need to hit. Just enter.
Oh, yeah, that's right.
Simulate time. All right, so we know right now that just by hitting enter that all of our simulatable objects just had simulate messaged on them. Now we know that they've been skeletoned in, but there's no actual implementation. There's no code in place, but we know it works. So that's good. So here's the problem. If I go to consume right now, because if I take a look at my fridge, everything is 85 degrees.
Oh,
And we all know that Nelson does not drink beer that is above 46 degrees. So let's see if this works. Let's consume. So we'll tell it to consume. The fridge says that a beverage has been removed. Nelson says, too warm. I'm not drinking that. And then fridge says a beverage has been added back in.
Well,
Well, look at that. All of these objects are interacting properly with one another. At this point, it is time for us to actually simulate our environment so that we can start having time go by. And we also need to simulate our blood alcohol count coming back down and things like that. It's not a lot of code, so if you guys are freaking out. But before we do that, we have 2 last things to check, and then I'm going to pause and make sure everybody's in good shape here. So we have to check quit. So let's just hit 5. And thank you for playing, and program has terminated properly. And then let's hit run again. And let's go ahead and say, let's look right into our fridge right away. 3. The fridge is empty, fool. Okay, good. So my program just called me a fool. Well, I love you too. So that worked well. But what happens right now if I type in 9 and hit enter? That's not very helpful. Let us go ahead and hit stop real quick. Revisit our main app. Let's come all the way down to default. And this is where we get to see default becoming very handy. I'm just going to come in here and simply do a log text. And from the system, we'll simply say invalid command. New line. And terminate that. And that's good enough. Let's test one more time and run. And so I want to type in 8 and hit enter and invalid command. And maybe I'll put a new line in there just to make it look a little bit nicer. So we'll just do a nice and neat little new line right here. Okay, so we know all of that works and everything is jamming along. So at this point, I'm going to go ahead and pause the video. Okay, and we are back, and students that are following along are caught up, and I'm so proud, so absolutely proud, as I just got finished helping Mr. Pencil with just a couple teeny little bitty things, and I'll tell you, it makes me want to cry. It's after 2 o'clock in the morning, and it's just exciting to see all of this stuff working so well. I mean, it really was. Okay, so great job. So now what we need to do is just handle time simulation. I mean, the program's working, everything except for what I had described at the beginning of how I wanted time to work so that we can then, well, drink and get Nelson drunk, which I'm sure he's dying for us to do. And
he's like, I got beer, I want to drink it.
And so, yeah, he's got beer, but it's too hot. Of course, in reality, he would probably not care and just go through it anyways. But let's go ahead and get these simulations in. So the very first one that I want to do with simulate is going to be our environment. So let me find over here, because at this point in time, I'm not going to trust myself to code anything without having some form of notes up. Because, well, my brain is like mush at the moment. So
your environment right there.
Where's my environment?
Over there.
That one?
Isn't that it? Environment state.
Then state that. I'm looking.
What the French?
French biscuits. Oh man, why did I say that?
I don't know.
Man, now I'm hungry.
Blarg. Wait a minute.
Here we go.
There.
It should be in here. That's because it wasn't open. I just again earlier I was just coding without using notes half the time, so that's kind of why I sound surprised that everything actually worked. It's like half and half.
Holy crap!
So now what I want to do is let's go ahead and jump. And I think if I recall, back over in our header, we had, everything is all in place there. We just need to go into the implementation and go to simulate. And what do we need to do for simulate?
Type some stuff.
And just type some stuff. It's real simple. We'll just, I mean, it really, blah, blah, blah. If we're going to increment time, so if time is greater than or equal to 24, since it's a 24-hour clock, let's simply take time and set it back to 1. Okay, so if we've reached midnight and gone right by it, we're going to say it's 1 o'clock. And then I want to come in here and do an NS string, and we'll do a text string object, and we'll say that it's going to be equal to NS string with format. And we'll say that the environment is going to give us a message this time around. So env will be from our environment, --. And it is now %LD colon and 00, so that we make it look a little more official, and a new line.
Yay.
And we just handed our time. And terminate, and let's print it out. So log and text, ha ha ha. So we've never imported our log header. So let me jump over here and import that.
You need to import your log.
So I need to import my log imported, back over to environment, continue typing. So text, and we want to just simply send out txt, like and then what I'm going to do is right here, just to verify, to prove everything was working, and I'll leave this code still visible, so let me adjust like such. So there's simulate for just environment. I'm going to rerun the app and test it. So start out, here's how I'm going to test it. What's in our store inventory? We currently have a bunch of stuff in there. Now let's just hit enter. Look at that. If you guys recall, when I instantiated our environment, I went ahead and preset the time in the init with time to 14 for 1400 for 2 o'clock in the afternoon. So here's the system telling us that we're going to simulate time, calling on everybody simulate, which we already had skeletoned in, but now we have our first implementation in place in environment, and look, our environment is telling us it's now 3 o'clock in the afternoon. So let's go ahead and run again.
1500.
As I come over here and completely, what did I hit?
I don't know.
Oh, I didn't stop it, did I? I don't know what I'm doing. So run it. So it's, all right, 1500. Yeah, I must have stopped it. So run it again. 1600. Run it again. 1700. 18, 19, 20, 21, 22, 23, 24. It's midnight. It's 1 o'clock in the morning. It's beer time. Now, the store is going to be closing around here, but we can't verify that yet. So here it is at 3 in the morning, and I want to make a purchase. And if I say I want to purchase, oh, well, look at that. We're closed. Go away. And Nelson says, purchase failed. Aww. So, and I can sit here and try to purchase all day long, and it's still going to fail. I can go ahead and take a look at my store inventory, and you can see we still have 10 in there. And now I just need to sit here and hit enter until the store opens back up. So 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock. And I think I did a greater than or equal to purchase. Yep, it needs to be 9 o'clock. So now they're open. So let's make a purchase. Yeah, ladies and gentlemen, look at that.
It's 5 o'clock somewhere.
The store is actually open, and we've removed beer from the store. And the fridge has had beer added to it.
Breakfast of champions.
So now we have, that's right, some early morning beer has been purchased. Well, it's not been consumed yet, so it's been put in the fridge.
True.
So now let's go ahead and work with our inventory for the store as far as simulate goes, because we know that we can just sit here and do this. Purchase, 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 and we have nothing to sell, go away. So let's make sure that we restock our store so that we have enough beer to get Nelson horridly drunk. So let's go ahead and switch back over to store. And again, we've already got simulate in place. Ooh, one moment though. First, anyone who's following along, if you still need to see that code for the first one, let me know, and I will pause and switch us back over there. But if all is working well, then we will go ahead and cruise on. Okay, I think we're working well. So let me go ahead and again back over at the store. And here's simulate. Let's go ahead and add some code into it. So this is so easy. All we're going to do is we're just going to say stock. Let's add an object. And what are we going to add? Well, we're going to take a beer and we're going to alloc it. And then we are going to initialize it with a temperature of, I don't know, let's give some nice cold.
Frosty.
Nah. Let's give these let's play. Let's give 70. So, yeah, good enough. So these guys are a little bit more chilled coming off the truck. So we'll go ahead and add that into the thing. And it's always a good idea to output something to the console so that we know stuff is working right. So let's go ahead and log this bad boy with a log, and we'll do text, and we'll simply say that the store added a new beer to the store. I'm not going to go through the headache of putting in the name. You guys know how to do that by now. You've seen it a million times. So new line, and boom. So let's go ahead. That's it. All I'm going to do is save, and run. So now, if I take a look at my store's inventory, by not typing up there, but typing down here, I'm so epic, and not purchasing, but by hitting a 2,
Oh, sweet.
we see that we have 10 beers in there. So if I just hit enter, boom, simulate time, it's now MMO Dust's store now has 412 beers in stock for your purchase. Awesome. So we can see that the environment now says it is indeed gone an hour later, and our store has let us know that we have a new beer in there. So now, to verify that all is working right, if I say, well, what does that mean that we currently have in our store inventory? We have 11.
Oh, see?
Oh, snap. All coming together.
Woo-hoo.
So let's go ahead and hit quit. We're almost there. Not quit. 5. I'm tired. So we're almost there, ladies and gentlemen. This is getting epic. So next thing I want to do is let's work with the fridge. Because as we know, the fridge is responsible for chilling our beer. So we're going to come over here, and again, over to Simulate, and let me make sure that I've got my notes so that I'm just following along on autopilot. So we're going to actually loop through all of the beer that is in the fridge, all of the beverages, and we'll lower everybody's temperature by their own modified temperature. So we'll simply say 4, and we're going to use fast enumeration, and we're going to say that this is any object that adopts the iBeverage, and we'll just simply call it Bev in Beverages is going to get $1 million. I
Yes.
wish. So now what I want to do is I'm just gonna just so that we don't end up with beer that'll like melt your face off. I'm gonna say if, and then we will simply say the beverage temperature is, if it's greater than 40,
You better cool that mamma jamma down.
then we're going to cool it down. And we'll just make a call to the beverage. And we'll simply say that we want to modify our temperature by what? Let's just take away, let's make it 10 degrees colder as each hour goes by. So now you can see why I don't want it to melt your face off, because, well, it could get really cold. So let's go ahead and save, and I'm going to run, leaving this code up in place for those of you that are wanting to or needing to still follow it. And I'm going to do a purchase, and it was at 85 degrees, and I have not let an hour advance yet. So let's go ahead and look at our store inventory. It should still be at that temperature. Or not store inventory. You guys got to correct me on this stuff. Fridge inventory. So it's 85 degrees. Let's let an hour go by. And the store got a new beer. An hour has gone by. And now let's take a look at what is in our fridge. So we'll go ahead and hit 3. 75. 70.
Heck yeah.
65. 60. 55. 50. So let's go ahead and take a look if that's what we're at. So store inventory, no. 3, fridge inventory, 35 degrees. Is that right?
I don't know. I don't know.
What could be possibly wrong?
I don't know.
You don't know.
Is it because we went we went past 40 or something. Wait.
I'm just waiting for someone to throw out the logic stuff. Come on, come on, come on.
What happened?
Oh, Nina, come on.
I'm trying. Okay, I'm thinking. It's current temperature, so it goes down 10 degrees. But only if it's greater than 40. So
let me do this. So stop, run. I'm going to do a purchase. And then we'll let an hour go by. And let's go ahead and take a look at what's in the fridge. So fridge inventory, 3. Yes, I don't know why I'm having such a hard time with that. So 75. Okay. Let an hour go by. What's in the fridge? 65. Right. Let an hour go by. What's in the fridge?
55.
55. Still greater than 40, right?
Still greater than 40 at this point.
So let an hour go by.
Right, so what I said, because it got to the point where it was less than 40, so then it...
So it's not going to go anymore. We didn't clip it at 40.
Right.
I love it. MMO Dust nailed it. He's like, looks fine to me. But sometimes it's just easy to like mess with people's mind with, oh my God, how did it get lower than 40? It's not possible. Well, if we look at our inventory now, we're at 45 degrees. We are greater than 40. So when it's cooling time, what is going to happen? So if we come in here, again, it's going to drop off 10 more degrees. And if we take a look at it now, my bad. That's actually simulate an hour. And then look at it, we drop 10 more degrees. Right. Now if I continue and say list, or let an hour run, list it, 35. Should still be 35. It stays 35. So now the final test. Nelson, time to drink. So let's go ahead and consume.
Consume that mamma jamma.
Uh-oh. Beer removed from the fridge. Nelson, time for beer. Throws his bottle in the trash can. I am impressed. That was tasty, but it didn't do much. All right. So Nelson's talking to us now. I like this. So let's go ahead and consume again. Can we consume another one?
I can't remember how many we
only had one in there.
Oh.
Fridge is empty, moron. Go buy beer. And let me fix that because it's driving me crazy. I like my messages being a little bit cleaner. So it's a message from our fridge. Message from your local sponsor. And I don't know why I put a new line right there. All right, I feel better. So let's go ahead and run. So we know that works. So let's go ahead and let's do some serious purchasing. Yay! Oh, we're out of stuff. Let's let some time go by because we know that right now Nelson's not going to drink anything till it's all freezing cold. Okay, that's probably good. Let's take a look at what is currently in our fridge. Nelson likes to drink a lot. Purchasing. Oh, they're closed.
No.
Yay, now they're open. I actually had to contend with real time and the darn thing being closed. All right, so let's now take a look at what we have in the fridge. Whoa. Now let's get our drink on. Time to consume.
It's time to get our drink on.
All right, beverage removed. Too warm. Oh, man. So, all right, beverage. Let's go ahead and consume beverage. Time for beer. Throws bottle in the trash. Good man. And that was tasty, but it didn't do much. Let's consume again. Time for beer. Still throws the bottle in the trash. And hey, everybody, I'm feeling awesome. So let's go ahead and consume again. Woo! Bottle falls to the ground. Was that a pony? Dude, it was. Let's go ahead and consume again. So same thing again. So saying, oh boy. So now it's like bottle falls to the ground, and I love ponies so much. I just want to hug them all. Let's consume again. I love you, man. Really, I do. Again. And let's just keep on going. Uh-oh, he's drunk. It's pony time. So now it's, time for ponies. And, oh, man, yeah, he's trashed. He's just screaming beer, and it's pony time. And so let's go ahead and consume some more. And, that's it.
He passed out on the couch.
Nelson has now passed out on the couch.
After screaming beer.
So after screaming beer. Well, remember, it's because beer's been removed from the fridge. He screamed beer, then he chugged it, and then the result of his chugging it was what was presented next. That's kind of how I've got it laid out.
Oh, this is awesome.
That's why it was always time for beer, but now it's not time for beer. Now it's just, he's passed out. So if we wanted to come in here and try to consume any more, as you guys can see, it is not possible. But here's the next problem we have. We need one final simulate. So I let all this time go by. And then I come in here and I say, all right, so we've let, I'll let a couple days go by, or a good day go by. All right, we've let a day go by, and now what I want to do is consume again. And Did I actually hit 4?
I thought you did.
Oh, yep. No, this is important. He still passed out because now we're not going to see his response to drinking a beer. So, no, this is exactly, he still passed out because
they put it back
beer
in
was
the
removed from the fridge. Nelson just gurgles, and so the beer was politely put back into the fridge. So who knows who got the beer out? It could have been me or Nina or somebody. And well, I would never do that because that would be like contributing to the delinquency of a minor. But anyways, yeah. So success, all is good. We just need to simulate now on person because we need for his blood alcohol content to bleed off over time. So let's go ahead and hit stop. And all right, the final thing we're going to do is revisit good old person and jump down to person's simulate. And simulate is just going to be a matter of backing off that stuff and make sure I didn't do anything else crazy in here. Oh, good heavens, I did. All right, so here we go. It won't be bad. We'll copy and paste. So first of all, if not is alive, then we want to just return because there's nothing to simulate if he's dead, right? Right. All right, so the next thing we want to do is we want to go ahead and so that we don't keep a repetitive message as time going by, we're going to actually take a reading of our current stage for our blood alcohol content, and then we're going to drop it down, and then we're going to compare to see if our new stage is the same as the stage it was a minute ago before it actually dropped down. And if they're still the same, meaning we haven't dropped down enough to go into the next zone of blood alcohol content into the next stage, we'll just return. So let's go ahead and rock and roll with that. So first thing is we're going to make a local variable called Backstage. And we'll say this is our old stage. And that's going to be equal to our Backstage, which I need to actually make a message call to. So self Backstage. All right, so now we're holding a reference to that. I mean, not a reference, but we're now holding a copy of that. So now we're going to say back is going to be equal to, and this is, if you guys recall, when I brought in math a while back, we're going to use a float max, and this is going to take the max of one of these two values. So we'll simply say that float max f is going to be 0 or a back minus 0.01. Okay, and the reason that we're doing this is so that we don't want to end up with a blood alcohol content level negative. So if we end up going negative, the maximum number would be 0 that would be taken. Otherwise, it's going to be anything else as long as it is a positive number. So we've now let this diminish. And so now, since we don't want to keep babbling off his state, I wanted to see the state continue being babbled off while we were trying to consume. But as I'm sitting here hitting enter over and over and over, I don't want a constant reminder that he's still passed out. So what I'll do here is simply say that if our old stage is still equal to what our new stage is, so let's go ahead and take a look at what the new stage is going to be by calling Backstage. So if they're equal to one another, oh man, you got to be kidding me. Thank you. So if they're equal to one another, we're just going to return. So we've already done what's required for simulate, which is making sure the blood alcohol content starts coming down. But now we can just have a little bit of fun with this real fast by making an NS string. And let's go ahead and call this same thing we've been doing. Now, I'm going to scroll back up and I'm going to grab one of these guys. Let me grab the one where slight buzz and all was actually being used together. Doesn't matter as long as you adjust this accordingly. So I'm going to scroll back down. So again, I just grabbed the big switch statement up there. And we're going to paste this down here at the bottom. And of course, I don't need the consume down here, which is why it's giving me an error. And then the things that I want to address will be normal. So let me make sure these are in place. Normal's there. And then I want slight buzz and buzz both to have the same thing. Good. I want emotional. And I want drunk. He's not going to come back from the dead. Since he's not coming back from the dead, we don't need unconscious in there. Because remember, this is a message that's going to be giving to us as he's coming back down off of being intoxicated. And the only way to hit unconscious would mean if we had just fallen from death back to being alive, and we don't support that. So let's go ahead and kill that out. All right, now let's just throw in some quick messages. So if we've just returned back to normal, we can have a very unhappy Nelson with something like, what is this? Not this, but this. So as you can see, he is very unhappy. And he needs to say, I need a drink. All right, good enough. Next thing I need to do is what happens if we are slight buzz or buzz? Let's just scream more beer. More beer. Because that sounds about right. Emotional. I love you, Nina. Pony biscuit. How do you spell biscuit? I'm so tired.
C-U-I-T.
C-U-I-T. Pony biscuit. Good. Mommy. There we go.
Whoa.
All right. So he's a little emotional right now. So if he's just come from unconscious to drunk, he's going to get up.
From the couch.
Gets up from couch, and then gets up from couch, and now he's going to say blah blah blah, blah pony. All right, because that reads about right.
That's awesome.
So that's it. And I know there's not enough vomiting. I didn't want to push it too far, though that would be very easy to add in. So I'm going to go ahead and do a Command S and Command Run. And we shall start out by, let's do this. Before testing that, I'm going to come back over here to my beer implementation. And I'm going to say that my back modifier is 10.02. So a beer will now consuming a beer will cause your blood alcohol content to shoot up to 10.02.
Oh, shoot.
So let's go ahead and run this.
Oh, my.
Let's purchase a beer. And let's
consume it.
Let's consume it. And what's going to happen when we try to consume it?
Oh, it's going to say it's too.
It's going to be too warm. So picky.
Time.
So now let's consume it. And good. So time for beer. And Nelson kills over dead and turns cold. Thanks to C-Buy. All right. So yeah, as you can see, Nelson is indeed dead. So if we try to purchase again and consume, oh crap, the fridge is empty. So I need to purchase, but they're closed. What? Purchase. Beer has been removed from the store. Beer has been added. I'll let you guys figure out where to put an extra piece of information here that just simply says that he's dead. Because, well, he's dead. So, okay, but, so anyways, he's not consuming anything because he is indeed dead. So that's good. So let's go ahead and put our beer back to what it was. There we go. I just wanted to test death, right? So
that's the poison beer.
So yeah, it was. So let's go ahead and run again, and let's just do a bunch of purchasing. Let's just let a lot of time go by, and then we're going to purchase. We're going to buy that store out. This is what happens when Nelson has a stolen credit card with unlimited funds. Oh, what are they closed for? Dumb people. So there you go. Now I'm starting to sound like Nelson. Dumb people. Store shouldn't close. That's stupid.
Stupid.
So at some point, boy, he's got a lot of beer. Oh, we have nothing to sell. Go away. What's in my fridge? That's what I'm talking about. Consumption time. So here we go. All right. So beverage removed. Not all right. So two. And so all right. So time for beer. Hey, bottle falls to the ground. Was that a pony? Woo. Yay. Stuff. Pony time. Yay. Passes out. Gurgles. And we just pull a beer out and put it back in. So now let's let time go by and see what happens. So we run it. So added another beer. Dang it, Nelson, you got up from the couch way too quick. All right, but it worked. And let's keep seeing. So at this point, Nelson got up from the couch and he's done a bit. So we just went over that limit, basically, to have him pass out. So let's run it again. And so look at this. Our state didn't change. Our blood alcohol level state didn't change. Even though the level changed, it went down by such a small amount, but the state didn't change. So we didn't say anything new. So let's go ahead and go again. Another beer was added. Let's go ahead and run again. And again. Oh, what did I mean? Oh, the program stopped. Oh, my bad. Man, hang on. That was my bad. Let me go ahead and buy this out again. Won't take me about a second. I'm hurrying. Simulating. Oh, they're closed. Open up. Buying. Nothing to sell. Let's go another 24 hours. Let's buy. That's good. And now let's let plenty of time go by.
For the beer to get cold.
And now let us go in here and start consuming.
Drink the crap
Consume.
out of some beer.
Good, good. Pony time. Yay. And good. And pony time. He's drunk. He's passed out. All right, so now he's just gurgling. So someone can hand him a beer all day long. And as you can see, no dice. So now let's let time pass. And he gets up from the couch. Blah, blah, blah. Let's let time go forward. We've added a beer, added a beer, added a beer. So 3 hours have gone by, 4 hours, 5. Uh-oh. Oh, wait. As you can see, it takes way too long for Nelson's effects to start wearing off because he would be sober by now. But we could simply go in there and make adjustments to our numbers. But here, we have indeed changed. I love you, Nina. Pony biscuit good, Mommy. So now we know he's emotional. So let's just even though it's a low amount, we can see that right here it just changed again. So now he's becoming a bit more coherent. More beer. All right, good. So let's go ahead and, so more beer, because now we switched from the buzzed to the slightly buzzed. So those two are going to share the same thing. So it's going to say more beer. And then let's go ahead and there we go. Nelson just dropped back down to normal. And what is this? I need a drink. So Nelson is now normal. And at this point, if we keep going through, nothing's going to happen because his blood alcohol level is now back to 0 and he's just sitting there waiting to drink. And if we were to start all over and do a purchase, a consume, you can see he's responding appropriately by drinking a beer, he's actually throwing the bottle in the trash and saying that was tasty. And the cycle begins. And ladies and gentlemen, here we are at almost 3 a.m. in the morning, and this is the entire app. And in just a second, I will make myself available for any help that any of you may need. But again, if we come all the way back over here to Photoshop, so many hours ago, when we started out with this very simple concept of wanting to have a person, a fridge, a beer, store to actually, sell the beer, an environment to keep track of time. We saw how we could use protocols to make items act as a particular type, so that we could then have different kinds of that type. For instance, we could have a beer, we could have a Coke, we could have et cetera, all of different things that are adopting the iBeverage protocol, and they are all considered iBeverage by the system. So we saw having the ability to simulate things by simply making them iSimulatable, having those objects adopt that. So all we needed to do was to put them in the simulations, into the simulations array, and then run through that with fast enumeration and calling each of theirs simulate. So yeah, there's been a lot of stuff that we have covered. And at this point, what I'm going to do is two things. I'll make an announcement on the forums because of the time, as it's approaching almost 3 o'clock in the morning. Let me jump back over to Xcode. I'm not going to hang up on you guys, but I am about to stop the recording because I am getting a little nervous about, we've got almost 5.5 hours of straight actual recorded video, and I don't want to run into a situation where the file has become too large and there's an audio interleave problem. So let me go ahead and jump over into Xcode. It's another thing I've been worried about for about the last hour. So I'm going to make ourselves available. I'm going to have another class session for you guys. That is not required. That it'll be Tuesday or Thursday night. I'll go ahead and say that now. I'll post it over in the forums. You don't have to show up, but you are more than welcome to. Instead of going over the homework, because it's kind of involved, and even making the post tonight will be death, as Nelson is dead, and I'm feeling that way. What we'll do is we'll make the post tomorrow, and then if any of you have any questions, please let us know in the homework thread. It will be making modifications to this application. I'll go ahead and give you one of the things that you'll be adjusting right now. You notice how with log that we needed to, every time we wanted to say who was the person that was spitting out the information, that we always had to type that in. So over in, I don't know, I mean, it's all over the place. Fridge, for example. You know, here we are saying fridge. It would be very cool to have a log that was able to be instanced. Whatever happened to John Doe? All I got to do is just instantiate a person without the init with name. That was just the catch in case anyone did an alloc init. But it's more fun instead of feeding John Doe lots of alcohol to feed it Nelson. So anyways, what would be nice would be to have a log that had instanced, or an instanced method, or however you want to do it, that each of these different classes that are using the log, upon instantiation, meaning in your constructor, in your initializer, actually instantiate the log and then register with it who you are, so that you don't have to keep sending this out every single time. So you would just simply log out a message with the, message, not the rest of it. That's one of a few things that you're going to be doing. This is going to be a bit more challenging. And I want to make myself available for you guys next week so that we can sit starting at normal hours when everybody's fresh and go over any problems that you guys may have had and answer questions. So I will announce that. And then there are a few more things that I would like to talk about as well, content-wise. But so there will be some education in it. But again, it's not a required class. Again, you guys are welcome to just watch. I'll record it, and you can watch the recorded videos. But anyways, I just remember, at the end of the day, the one thing I love about my job is I have always cared greatly about the students that are motivated and truly wanting to learn this stuff. And, you know, you guys out there right now that have hung in here all night long, I mean, geez, this is the longest we've gone yet. I'm so impressed. You guys are absolutely amazing, and I truly appreciate it. And I'm more interested in making sure you guys get every bit of education I can possibly hand to you. So I just want you to know where I'm coming from. So Ashley, if you're not asleep, I'm just saying I'm not trying to make classes super, super long. Yeah, dedication. Both from you guys being dedicated makes me dedicated because I love seeing students that really want to learn this stuff. And, oh, that's awesome, Mr. MMO, that you learned a lot more about memory management. And see, I also want to spend a bit of time going over the automatic reference counting as well. But and I'm not going to pull that out, so I'll put that into a video next week. But I thought putting an entire application like this together would be both fun, challenging, and educational. So hopefully, for those of you that truly followed along, you found that to be the case. But anyways, so I'm going to wrap up the recording, but I'm not shutting down the webinar so that anyone who needs help, I'll be more than happy to help you guys. So that is going to conclude this video. For those of you that are watching the future version of this video, please make sure to check out the forum for the homework stuff. And that concludes tonight's class.
Bye.
Thank you guys very much. Goodbye.